The ocean holds many secrets, but perhaps none as chilling as the sounds it carries across its vast expanse. Beneath the rhythmic crash of waves and the whistle of sea winds lies something far more disturbing. Screams that echo from the depths, wails that have no visible source, and cries that defy explanation. These aren't the metaphorical screams of wind through rigging or the groaning of stressed metal. These are sounds that chill the blood of even the most experienced mariners, acoustic phenomena that blur the line between the natural and the supernatural. Today, we'll explore 18 of the most terrifying and unexplained screaming events ever recorded at sea. From ghostly wails that persist decades after maritime disasters to mysterious cries captured in the deepest trenches, these stories will challenge everything you think you know about what lurks beneath the waves. So settle in, perhaps check that your doors are locked, and prepare yourself for a journey into the screaming ocean, where sound itself becomes a harbinger of terror. Let's begin our descent into the unknown. Our first tale takes us to the treacherous waters off Vancouver Island, where the ghosts of the past refuse to rest in silence. It begins on a stormy January night in 1906, when the passenger steamer Steamship Valencia met her doom against the unforgiving rocks of the Pacific Northwest coast. But this isn't just another story of maritime disaster. This is a tale of screams that echo across more than a century, defying explanation and chilling anyone brave enough to venture near the site of one of Canada's worst shipwrecks. The steamship Valencia was a 1,598-ton passenger steamer, carrying 164 souls through the violent winter storms that regularly lash the coast of British Columbia. On January 22, 1906, thick fog and howling winds drove the vessel off course, sending her crashing into the jagged rocks near Pachena Point on Vancouver Island's west coast. What followed was a nightmare of survival that would haunt maritime history forever. As the ship began breaking apart on the razor-sharp rocks, passengers and crew found themselves trapped in a death trap of twisted metal and rising water. The most horrifying aspect wasn't the cold Pacific waters or the relentless pounding of the waves. It was the sounds that emerged from the dying vessel. Blood-curdling screams from passengers trapped in the ship's lower holds, their cries carrying across the water as the hull cracked and groaned under the ocean's assault. Survivors who managed to escape the wreck in lifeboats reported that the screaming continued for hours as the ship slowly disintegrated. More than 100 people perished that night, many of them trapped below decks as the vessel broke apart section by section. The screams of the dying mingled with the crash of waves and the shriek of tearing metal, creating a symphony of terror that would echo in the survivors' memories for the rest of their lives. But here's where the story takes a turn from historical tragedy to unexplained mystery. The screaming never stopped. Decades after the steamship Valencia disappeared beneath the waves, mariners passing through the area began reporting something impossible. During storms, when conditions mirror those of that terrible night in 1906, sailors hear screams coming from the water near Pachena Point. Not the cries of living people in distress, but the same blood-curdling screams that witnesses described from the original disaster. The first documented report came just 10 years after the wreck, when a fishing vessel sought shelter near the site during a violent storm. The crew reported hearing human screams carried on the wind, sounds so clear and terrifying that they launched a rescue search despite the dangerous conditions. They found nothing but empty ocean and the ghostly outline of rocks that had claimed the Valencia decades earlier. Since then, the reports have continued with disturbing regularity. Commercial fishing boats, pleasure craft, and even Coast Guard vessels have documented similar experiences. The screams are always described the same way. Human voices crying out in terror and desperation, clear enough to understand as cries for help, yet coming from empty water where no living person could survive. What makes these reports particularly unsettling is their consistency. The screams are only heard during storms, particularly when fog reduces visibility, and waves crash against the rocks with the same fury that destroyed the Valencia. The sounds seem to emanate from the exact location where the ship went down, as if the ocean itself has become a recording device, playing back the final moments of those who died there. Maritime experts have proposed several theories to explain these phantom screams. The most rational suggests that the sounds are acoustic phenomena created by wind passing through underwater caverns and rock formations near the wreck site. The specific geology of the coastline, combined with certain atmospheric conditions, might create sounds that the human brain interprets as screams. Another theory focuses on the psychological impact of the location itself. The waters off Vancouver Island are notorious for their danger, and sailors approaching the area with knowledge of the Valencia disaster might be primed to interpret natural sounds as something more sinister. The power of suggestion, combined with the stress of navigating treacherous waters during a storm, could transform ordinary ocean noises into perceived human cries. But these explanations struggle to account for the specificity of the reports. Why do the screams only occur near this particular wreck site? Why do multiple independent witnesses describe nearly identical sounds? And why do the screams seem to follow the same pattern as those reported during the original disaster? The oceanographic conditions around the Valencia wreck site add another layer of mystery. The area is characterized by powerful currents, sudden depth changes, and underwater rock formations that create complex acoustic environments. Sound travels differently underwater than in air, and the specific bathymetry of the region might create acoustic focusing effects that concentrate and amplify certain frequencies. Yet, despite extensive study of the area's acoustic properties, no definitive explanation has emerged for the phantom screams. Underwater surveys have located scattered debris from the Valencia, confirming the wreck's location, but the remains of the ship itself were never substantially recovered. The hull, along with many of the victims, simply vanished into the depths, claimed by the same treacherous currents that make the area so dangerous for modern vessels. For the families of those lost aboard the Valencia, the reports of ongoing screams have created a complex emotional legacy. Some find comfort in the idea that their ancestors' voices might still be heard, a form of eternal memorial to their suffering. Others find the reports deeply disturbing, suggesting that the victims' spirits remain trapped and tormented at the site of their death. Local indigenous communities have their own interpretation of the phenomenon. The Pachidot First Nation, whose traditional territory includes the wreck site, speaks of places where the boundary between the living and spirit worlds becomes thin. According to their beliefs, locations where many people died violent deaths can become permanent openings to the spirit realm, places where the voices of the departed continue to call out. The screams of the steamship Valencia have become part of the broader folklore surrounding one of the most dangerous stretches of coastline in North America. The Graveyard of the Pacific, as the waters off the Pacific Northwest are known, has claimed hundreds of vessels over the past 2 centuries. But none has left such an audible legacy as the Valencia, whose victims seem to cry out still from their watery grave. Modern technology has allowed researchers to study the phenomenon more systematically. Hydrophones deployed near the wreck site have captured acoustic anomalies during storm conditions, though interpreting these recordings remains challenging. Some contain sounds that could be interpreted as human-like, while others show only the expected noise signatures of wind, waves, and moving water. The mystery of the Valencia's screaming ghosts remains unsolved, a reminder that the ocean holds secrets we may never fully understand. Whether the sounds are acoustic phenomena, psychological manifestations, or something beyond our current scientific understanding, they continue to terrify and fascinate those who encounter them. For mariners who must navigate these treacherous waters, the screams serve as an eternal warning about the sea's capacity for sudden violence. They remind us that beneath the ocean's surface lie the untold stories of those who ventured out and never returned, their final moments preserved somehow in the memory of the water itself. The next time you find yourself near the ocean during a storm, listen carefully to the sounds carried on the wind. What you hear might be nothing more than the natural voice of the sea. Or it might be something far more unsettling, the echo of human voices, calling out across time, reminding us that some tragedies leave marks that even the passage of decades cannot erase. If you're captivated by these chilling maritime mysteries and want to dive deeper into the ocean's darkest secrets, consider joining our crew by hitting that subscribe button. Each subscription is like a lighthouse in the storm, guiding us to create more spine-tingling explorations of the unknown. Plus, you'll be the first to hear when new mysteries surface from the depths. Your support keeps us sailing through YouTube's treacherous waters, and trust me, we've only just begun to explore the screaming secrets hidden beneath the waves. Story 2. The Lost Divers of the Blue Hole. From the phantom screams echoing across stormy Canadian waters, we now descend into the crystalline depths of the Caribbean, where one of Earth's most magnificent geological formations has become the setting for an equally chilling mystery. The Great Blue Hole of Belize stands as a testament to the ocean's power to create both breathtaking beauty and deadly peril. This perfectly circular sinkhole, 400 feet deep and nearly 1,000 feet across, appears from above like a sapphire jewel set in turquoise waters. But beneath its stunning facade lies a darkness that has claimed lives and left behind questions that echo as hauntingly as any ghostly scream. The Great Blue Hole was formed during the last ice age, when sea levels were much lower, and the site was a dry limestone cave system. As the ice melted and oceans rose, the cave ceiling collapsed, creating the massive underwater sinkhole we see today. Its walls drop away into an abyss so deep that sunlight barely penetrates the lower reaches, creating a vertical underwater desert where few creatures dare to venture. For experienced divers, the Blue Hole represents the ultimate challenge, a chance to descend into one of the most unique environments on the planet. But this geological wonder is far from a benign tourist attraction. The hole's extreme depth, combined with its enclosed nature and unique water chemistry, creates conditions that can disorient even the most skilled underwater explorers. Nitrogen narcosis sets in at relatively shallow depths, while the lack of visual references in the hole's featureless walls can cause psychological disorientation that has proven fatal. It was against this backdrop of natural beauty and hidden danger that one of the ocean's most disturbing mysteries unfolded in the early months of 2018. Two experienced divers, drawn by the allure of exploring this underwater cathedral, would venture into the Blue Hole's depths and vanish without a trace, leaving behind only the echo of screams that no one should have been able to hear. The divers had arrived in Belize as part of a small expedition, equipped with advanced diving gear and years of deep water experience between them. The Blue Hole, while challenging, was within their skill range, and conditions on the surface appeared ideal for the dive. Clear skies, calm seas, and excellent visibility promised a perfect opportunity to explore the geological marvel that had captivated divers from around the world. Local dive operators, however, had noticed something unusual that morning. As the dive boat approached the Blue Hole, several crew members reported hearing faint sounds carried across the water, sounds that seemed almost like distant human voices. At first, these were dismissed as tricks of the wind, or perhaps distant radio chatter from other vessels. The Caribbean waters are busy with boat traffic, and sound can travel surprising distances across calm seas. But as the divers prepared for their descent, the sounds became more distinct and more disturbing. Multiple witnesses described hearing what could only be characterized as screams, faint but unmistakably human, seeming to rise from the Blue Hole itself. The cries were so clear that the dive boat crew initially thought another diving party might be in distress somewhere in the area. A quick radio check revealed no other dive operations in the immediate vicinity, and visual scanning of the surrounding waters showed no sign of boats or divers in distress. Yet the screaming continued, growing slightly louder and more urgent as the morning progressed. The sounds seemed to emanate directly from the dark waters of the Blue Hole, as if something far below the surface was crying out for help. Despite the unsettling audio phenomenon, the dive proceeded as planned. The two divers entered the water and began their descent into the Blue Hole's depths, their progress tracked by the surface support team through standard diving protocols. For the first portion of the dive, everything appeared normal. Radio communications were clear, depth readings were as expected, and the divers reported no unusual conditions. Then, approximately 20 minutes into the dive, communication was lost. The surface team initially attributed the communication failure to the Blue Hole's notorious radio dead zones, where the limestone walls and water chemistry can interfere with electronic signals. Standard protocol called for divers to surface if communication was lost for an extended period, so the support crew waited for the divers to emerge on their own. But the divers never surfaced. As the minutes stretched into hours, it became clear that something had gone catastrophically wrong. Emergency protocols were activated, and one of the most extensive underwater search operations in Caribbean diving history was launched. Professional rescue divers, equipped with advanced life support and communication gear, descended into the Blue Hole to search for their missing colleagues. What they found defied explanation. Despite covering every accessible portion of the Blue Hole's interior, search teams discovered no trace of the missing divers. No equipment, no air bubbles, no bodies, nothing to indicate what had happened to two experienced divers who had simply vanished into the depths. The absence of any physical evidence was particularly puzzling given the Blue Hole's enclosed nature. Unlike open ocean diving, where currents could carry a body or equipment far from the dive site, the Blue Hole is essentially a giant underwater bowl. Anything that sinks into its depths should remain there, gradually settling to the bottom where it could be recovered by search teams. Yet despite multiple search expeditions using progressively more sophisticated equipment, including remote-operated vehicles capable of reaching the blue hole's deepest points, no trace of the missing divers was ever found. It was as if they had simply dissolved into the dark water, leaving no evidence of their fate. The mystery deepened when investigators attempted to correlate the timing of the divers' disappearance with the strange screaming sounds reported earlier that morning. Witness accounts varied, but several crew members insisted that the screaming had stopped abruptly around the same time communication was lost with the missing divers. The implication was deeply unsettling. Had the mysterious cries been somehow connected to whatever fate befell the divers? Theories about what happened to the missing divers range from the scientifically plausible to the darkly speculative. The most straightforward explanations focus on the known dangers of blue hole diving. Nitrogen narcosis could have caused disorientation, leading to a fatal error in judgment. Equipment failure at depth could have prevented the divers from surfacing safely. An underwater landslide or collapse of part of the hole's wall could have trapped them beneath tons of debris. But these conventional explanations struggle to account for the complete absence of any physical evidence. Even in cases of catastrophic equipment failure or geological collapse, some trace of divers or their gear typically remains recoverable. The blue hole's relatively contained environment should have made recovery more likely, not less. More exotic theories focus on the unique environmental conditions within the blue hole itself. The formation's extreme depth creates distinct thermoclines where water temperatures and chemistry change dramatically. These conditions might create powerful underwater currents or pressure differentials that could trap or disorient divers. Some researchers have suggested that the blue hole's limestone walls might create acoustic effects that could interfere with a diver's sense of direction or depth perception. The question of the screaming sounds adds another layer of complexity to the mystery. If the cries were somehow connected to the diver's fate, what could explain sounds being heard at the surface before the divers had even encountered whatever danger claimed them? Was it possible that the sounds were actually the divers' final distress calls, somehow transmitted through the water and limestone in ways that conventional physics couldn't explain? Local beliefs offer alternative explanations rooted in Caribbean folklore and indigenous traditions. Some Belizean communities have long regarded the blue hole as a sacred site, a place where the boundary between the physical and spiritual worlds becomes thin. According to these traditions, certain locations in the ocean can trap souls, preventing them from passing on after death. The screaming sounds might represent the voices of previous victims, calling out warnings to those who venture too close to the hole's dangerous depths. Marine biologists studying the blue hole have documented several species of deep-water creatures that inhabit its lower reaches, including sharks and rays that rarely venture into shallower waters. While attacks by marine life are extremely rare in the area, the possibility that an unknown predator might lurk in the hole's deepest unexplored regions cannot be entirely dismissed. Some theories suggest that a large, aggressive species might inhabit the blue hole's depths, explaining both the diver's disappearance and the mysterious screaming sounds. The acoustic properties of the blue hole itself present another avenue for investigation. The formation's circular shape and limestone composition create a natural resonating chamber that might amplify or distort sounds in unexpected ways. Geological activity, gas releases from decomposing organic matter, or even the movement of large marine animals could potentially create sounds that reach the surface as distorted, scream-like noises. Recent technological advances have allowed researchers to study the blue hole's acoustic environment more systematically. Hydrophones lowered into the formation have captured a variety of sounds, from the expected geological creaking to more unusual acoustic signatures that defy easy categorization. Some recordings contain sound patterns that could be interpreted as vocalizations, though whether these represent marine life, geological phenomena, or something else entirely remains unclear. The disappearance of the two divers has had a lasting impact on the diving community and blue hole tourism. While the site remains a popular destination for experienced divers, new safety protocols have been implemented, including mandatory buddy systems, enhanced communication equipment, and restrictions on dive depths and durations. The mystery has also sparked increased scientific interest in the blue hole's unique environment, leading to more comprehensive studies of its geology, biology, and acoustic properties. For the families of the missing divers, the absence of answers has created a unique form of grief. Without bodies to recover or a clear understanding of what happened, closure remains elusive. The possibility that their loved ones might have suffered in the depths, perhaps calling out for help as suggested by the mysterious screaming sounds, adds a particularly haunting dimension to their loss. The Blue Hole continues to guard its secrets, a reminder that even in our age of advanced diving technology and underwater exploration, the ocean retains its capacity to claim lives without explanation. The combination of natural beauty and hidden danger that characterizes this geological wonder serves as a metaphor for the sea itself, magnificent and inviting on the surface, yet concealing depths that remain largely unknown and potentially deadly. As we continue our journey through the ocean's screaming mysteries, the case of the Blue Hole's lost divers stands as a stark reminder that some of the sea's most beautiful locations can also be its most dangerous. The screams that echoed across the Caribbean waters that morning in 2018 may have been a warning, a plea for help, or something else entirely. But they serve as an eternal caution that in the ocean's depths, even the most experienced explorers can vanish without a trace, leaving behind only questions and the haunting echo of their final moments. Story 3. The Screaming Depths of the Tonga Trench. From the azure depths of the Caribbean's Blue Hole, we now journey to one of the most extreme environments on our planet, the Tonga Trench, where the Pacific Ocean plunges to depths that challenge our understanding of life itself. This underwater chasm, stretching for over 850 miles through the South Pacific, represents one of the deepest scars on Earth's surface, reaching depths of more than 35,000 feet. Here, in conditions of crushing pressure and eternal darkness, scientists have encountered phenomena that blur the line between the geological and the supernatural, including sounds that should be impossible. Screams that seem to rise from the very bowels of the earth. The Tonga Trench sits at the boundary between two massive tectonic plates, where the Pacific Plate is being forced beneath the Indo-Australian Plate, in a process that has continued for millions of years. This collision zone creates one of the most geologically active regions on the planet, where underwater earthquakes, volcanic eruptions, and massive landslides occur with disturbing regularity. The trench itself is like a wound in the ocean floor, a place where the Earth's crust has been torn apart to reveal the molten forces that churn beneath. In 2015, an international deep-sea research expedition set out to explore the deepest accessible portions of the Tonga Trench, equipped with state-of-the-art submersible technology and scientific instruments designed to withstand the crushing pressures found at such extreme depths. The mission was ambitious, to study the unique ecosystem that might exist in one of Earth's most hostile environments, and to better understand the geological processes that create such massive underwater formations. The research vessel positioned itself above one of the trench's deepest sections, where sonar readings indicated depths exceeding 32,000 feet. At such depths, the pressure reaches more than 1,000 times greater than at sea level, enough to instantly crush any conventional structure. Only the most sophisticated submersibles, built like underwater spacecraft, could hope to survive the descent into this alien environment. As the submersible began its lengthy journey to the bottom of the trench, carrying a crew of 3 researchers and a pilot, everything proceeded according to plan. The descent would take several hours, during which the team would deploy various scientific instruments and record observations about this largely unexplored environment. Communication with the surface vessel was maintained through a sophisticated tether system designed to function at extreme depths. But as the submersible approached the 30,000-foot mark, something extraordinary and terrifying occurred. The hydrophones monitoring ambient sound in the water began picking up acoustic signatures unlike anything the research team had ever encountered. The sounds were rhythmic, high-pitched, and unmistakably resembled human screaming. At first, the research team assumed the sounds were some form of equipment malfunction or interference. The extreme conditions in the trench could affect electronic equipment in unpredictable ways, and false readings were not uncommon at such depths. But as the submersible continued its descent, the screaming sounds grew louder and more distinct, transmitted through the water with a clarity that made them impossible to dismiss as technical glitches. The sounds appeared to be coming from multiple sources, as if dozens of voices were crying out in unison from the deepest parts of the trench. The frequency and pattern of the screams suggested human vocalizations, but the location made this impossible. No human could survive at such depths, and no equipment capable of producing such sounds had ever been deployed in the area. As the submersible reached its maximum operational depth, still several thousand feet above the trench's deepest point, the screaming reached a crescendo that was both fascinating and terrifying to the research team. The sounds were being recorded on multiple independent systems, ruling out the possibility of a single equipment failure. Whatever was creating these noises was real and located somewhere in the crushing depths below them. Then disaster struck. Without warning, multiple critical systems aboard the submersible began to malfunction simultaneously. The main power systems experienced unexplained fluctuations. Life support systems showed anomalous readings, and most critically, the ballast tanks that controlled the submersible's buoyancy began to behave erratically. The vessel, which had been maintaining its depth through precise control of these systems, suddenly found itself in danger of an uncontrolled descent into the trench's deepest reaches. The screaming sounds, which had been growing steadily louder during the descent, abruptly stopped as the equipment failures began. This correlation was noted by the research team, but at the time their focus was entirely on the life-threatening emergency that had developed. An uncontrolled descent to the bottom of the Tonga Trench would mean certain death for all aboard, as even their specialized submersible was not designed to withstand the pressures at the trench's maximum depth. Emergency protocols were immediately activated. The surface support vessel began procedures to assist with the submersible's emergency ascent, while the crew aboard the underwater craft worked frantically to restore critical systems. The ballast tanks were purged manually, and emergency ascent procedures were initiated, but the submersible's behavior remained unpredictable and dangerous. The ascent from 30,000 feet proved to be one of the most harrowing emergency recoveries in deep-sea exploration history. Multiple systems continued to malfunction during the rise to the surface, requiring constant manual intervention by the crew. At several points, the submersible's ascent rate became dangerously fast, threatening to cause decompression damage to both the vessel and its occupants. After more than 6 hours of emergency procedures, the submersible finally reached the surface, its crew shaken but alive. However, the expedition was cut short, and the planned exploration of the trench's deepest sections was abandoned. The equipment failures had been too extensive and too dangerous to risk another descent, even after repairs. Post-mission analysis of the submersible systems revealed something deeply puzzling. While multiple systems had indeed malfunctioned during the dive, technical examination could find no clear cause for the failures. The equipment appeared to be in working order, with no signs of damage, corrosion, or manufacturing defects that could explain the simultaneous breakdowns. It was as if the submersible's systems had simply chosen to stop working properly at the worst possible moment. More intriguing were the acoustic recordings captured during the dive. The hydrophone data clearly showed the presence of the screaming sounds, recorded across multiple frequencies and with sufficient clarity to rule out background noise or interference. Analysis of the audio revealed patterns that were remarkably similar to human vocalizations, with frequency ranges and modulations that closely matched distressed human screaming. Yet the source of these sounds remained completely mysterious. No known geological processes could create audio signatures so similar to human voices. While underwater volcanic activity, gas releases, and tectonic movement can create various sounds, none typically produce the complex frequency patterns and rhythmic qualities heard in the Tonga Trench recordings. Marine biologists studying the recordings suggested the possibility that unknown deep-sea creatures might be responsible for the sounds. The deepest parts of ocean trenches remain largely unexplored, and it's possible that species adapted to such extreme conditions might have evolved unique communication methods. However, the complexity and human-like quality of the vocalizations would require a level of sophistication unprecedented in known marine life. Geological explanations focus on the unique acoustic properties of the trench environment. The extreme depth and enclosed nature of oceanic trenches can create acoustic focusing effects that might amplify and distort sounds from various sources. Gas releases from underwater volcanic activity or sediment movement could potentially be transformed by these acoustic effects into sounds that resemble human voices. Another theory suggests that the sounds might be related to the movement of water itself within the trench's unique environment. The circulation patterns in deep oceanic trenches are complex and poorly understood, involving the interaction of extremely dense, cold water with the trench's steep walls. Under certain conditions, These water movements might create acoustic phenomena that could be interpreted as vocalizations. The correlation between the screaming sounds and the equipment failures aboard the submersible has led to more speculative theories. Some researchers have suggested that intense acoustic energy might be capable of interfering with electronic systems, particularly in the specialized equipment required for deep-sea exploration. If the source of the screaming is producing high-intensity sound waves, these might have been sufficient to disrupt the submersible's sensitive instruments. More exotic theories propose that the extreme conditions in the deepest parts of oceanic trenches might create physical phenomena that science doesn't yet understand. The combination of crushing pressure, minimal temperature, and complete isolation from surface conditions creates an environment unlike anywhere else on Earth. It's possible that these conditions allow for acoustic or electromagnetic phenomena that don't occur in more conventional environments. The Tonga Trench expedition has influenced subsequent deep-sea research missions, leading to enhanced acoustic monitoring protocols and improved emergency procedures for extreme depth exploration. Several follow-up expeditions have attempted to return to the area where the screaming was recorded, but technical challenges and the extreme danger of such deep exploration have limited these efforts. Recent advances in autonomous underwater vehicles have allowed for some limited exploration of the trench's deeper regions without risking human lives. These robotic explorers have captured additional acoustic data from the trench, including recordings that contain similar screaming-like sounds, though none as clear or extensive as those recorded during the 2015 manned expedition. The mystery of the Tonga Trench's screaming depths remains one of the most compelling enigmas in modern oceanography. The combination of extreme environmental conditions, unexplained acoustic phenomena, and life-threatening equipment failures creates a perfect storm of scientific mystery and maritime danger. For the researchers who experienced the event firsthand, the memory of those screaming sounds rising from the deepest parts of the ocean remains vivid and unsettling. They describe the experience as fundamentally changing their understanding of the ocean's depths, forcing them to confront the possibility that the most extreme environments on our planet might harbor phenomena that challenge our scientific understanding. The Tonga Trench serves as a reminder that even in our age of advanced technology and scientific understanding, the deepest parts of our planet remain largely unknown. The screams that echo from its depths might be geological, biological, or something else entirely, but they represent the voice of a frontier that humanity has barely begun to explore. In the crushing darkness of the deepest ocean trenches, where pressure and isolation create conditions unlike anywhere else in the known universe, the impossible might indeed be possible, and the screams of the deep might be trying to tell us something we're not yet ready to understand. Story 4. The Phantom Screams of the Sunda Strait. From the crushing depths of the Tonga Trench, we now sail to the shallow but volatile waters of the Sunda Strait, where one of history's most catastrophic volcanic eruptions created a legacy of terror that refuses to fade. The strait, nestled between the Indonesian islands of Java and Sumatra, bears witness to one of nature's most destructive forces, the volcano Krakatoa. But the screams that echo across these waters tell a story that extends far beyond the geological violence of that infamous day in 1883, reaching into realms where science struggles to provide answers, and where the line between natural phenomenon and supernatural occurrence becomes dangerously thin. On August 27, 1883, the world witnessed what many consider the most violent volcanic eruption in recorded history. Krakatoa, a volcanic island that had slumbered peacefully in the Sunda Strait for 2 centuries, suddenly exploded with a force that defied human comprehension. The eruption was so powerful that it was heard 3,000 miles away in Australia and the island of Rodrigues near Mauritius. The sound waves circled the Earth multiple times, and the ash cloud reached heights of 50 miles, plunging much of the region into darkness for days. The immediate death toll was staggering. The eruption triggered tsunamis that reached heights of over 130 feet, wiping out entire coastal communities and killing an estimated 36,000 people across the Indonesian archipelago. Ships in the strait were either destroyed by the blast itself or swept away by the massive waves that followed. The very island of Krakatoa was nearly obliterated, with 2/3 of its landmass collapsing into the sea, leaving only scattered remnants of what had once been a substantial volcanic cone. But it was not just the physical destruction that marked this catastrophe. Sailors who survived the initial blast reported hearing something that would haunt maritime folklore for generations, human screams carried across the water, distinct from the roar of the explosion and the crash of waves. These were the cries of the thousands of victims caught in the tsunami's path, their final moments echoing across the strait as entire communities were swept into the sea. What transforms this historical tragedy into an enduring mystery is what happened in the weeks and months that followed. According to numerous documented accounts, the screaming did not end with the eruption. Ships passing through the Sunda Strait continued to report hearing human voices calling across the water, sounds of distress and terror that seemed to have no visible source. The first post-eruption reports came from Dutch naval vessels conducting rescue and reconnaissance missions in the devastated strait. Officers documented hearing what they described as the voices of the lost during calm evening hours, when the wind was still and the water relatively peaceful. The sounds were distinct enough that several ships diverted course to investigate, believing they had encountered survivors clinging to debris or stranded on previously unknown islands. These search efforts consistently found nothing. The waters where the screams seemed to originate contained no survivors, no wreckage that could harbor human life, and no geographical features that could explain the acoustic phenomenon. Yet the reports continued with disturbing regularity, described by multiple independent sources with remarkable consistency. The screaming sounds reported in the Sunda Strait possess several distinctive characteristics that set them apart from other acoustic mysteries. Unlike the phantom voices reported at other maritime disaster sites, these sounds seem to occur in waves, building to crescendos before fading away, only to return hours or sometimes days later. The pattern suggested not random acoustic phenomena, but something more organized, almost as if the screams were following some invisible schedule. Witnesses consistently described the voices as human, distinctly different from wind, waves, or mechanical sounds. The screams carried emotional content that was unmistakable: terror, desperation, and pleading. Some reports included what appeared to be words or phrases in local Indonesian languages, though the exact content was often too distorted by distance and atmospheric conditions to understand clearly. The timing of these phantom screams followed patterns that deepened the mystery. They occurred most frequently during periods of calm weather, when atmospheric conditions were stable and sound could travel long distances across the water. Storms and high winds seemed to suppress the phenomenon, leading some to theorize that specific atmospheric conditions were necessary for whatever process was creating the sounds. More puzzling was the apparent correlation between the screams and ongoing volcanic activity in the region. The Sunda Strait remained geologically active after the 1883 eruption, with new volcanic islands emerging from the sea and underwater gas vents releasing superheated gases into the water column. Some witnesses reported that the screaming sounds intensified during periods of increased geological activity, as if the Earth's unrest was somehow amplifying whatever force was creating the phantom voices. Scientific investigation of the phenomenon began almost immediately after the initial reports. Dutch colonial authorities, concerned about the potential impact on shipping in this vital maritime corridor, commissioned several studies to determine the cause of the acoustic anomalies. Early theories focused on geological explanations: gas releases from underwater volcanic vents, the movement of superheated water creating convection currents, or the settling of debris from the eruption, creating unusual acoustic conditions. The geological explanation gained credibility when researchers discovered that the Sunda Strait's underwater topography had been dramatically altered by the eruption. The collapse of Krakatoa had created a complex underwater landscape of caverns, channels, and unstable rock formations. Water moving through these structures under certain conditions might create sounds that could be interpreted as human voices, particularly when filtered through the psychological expectations of sailors aware of the area's tragic history. Gas release theories focused on the ongoing volcanic activity beneath the strait. Underwater volcanic vents can release various gases at different temperatures and pressures, creating acoustic phenomena as the gases interact with seawater and rise to the surface. The specific chemistry of volcanic gases from the Krakatoa system might create sound patterns that, under certain atmospheric conditions, could be perceived as human vocalizations. However, these rational explanations struggled to account for the specificity and consistency of the reports. If the sounds were purely geological, why did they so consistently resemble human distress calls? Why did multiple independent witnesses describe nearly identical acoustic patterns? And why did the phenomenon seem to follow temporal patterns that didn't correlate directly with measurable geological activity? Alternative theories emerged that focused on the psychological and cultural dimensions of the mystery. The Sunda Strait had become synonymous with one of the greatest natural disasters in human history, and ships passing through the area carried crews who were acutely aware of the tragedy that had occurred there. The power of suggestion, combined with the stress of navigating waters known for their danger, might cause sailors to interpret ordinary sounds as something more sinister. This psychological explanation gained support from studies of similar phenomena at other disaster sites, where witnesses reported hearing voices or seeing apparitions that appeared to be connected to historical tragedies. The human brain's pattern recognition systems are particularly sensitive to sounds that resemble human speech, and under conditions of stress or expectation, these systems might interpret ambiguous audio stimuli as voices. But the psychological theory also faced challenges. The reports came from professional mariners trained to distinguish between different types of sounds and accustomed to the acoustic environment of ships and sea. Many of the witnesses had no prior knowledge of the screaming phenomenon before experiencing it themselves, reducing the likelihood that their reports were influenced by existing folklore or expectation. Local Indonesian communities contributed their own interpretations of the phantom screams, drawing on traditional beliefs about the relationship between natural disasters and the spirit world. According to Javanese and Sumatran folklore, locations where many people died violent deaths become thin places where the boundary between the physical and spiritual worlds becomes permeable. The massive loss of life during the Krakatoa eruption might have created such a condition in the Sunda Strait, allowing the voices of the victims to persist in the physical world. These cultural explanations provided a framework for understanding the phenomenon that Western science struggled to address. Traditional Indonesian maritime practice had long recognized certain areas of the ocean as spiritually active, places where navigators needed to show proper respect for the forces that dwelt there. The phantom screams of the Sunda Strait fit naturally into this worldview, representing the ongoing presence of those who had perished in the volcanic catastrophe. Modern technology has allowed for more sophisticated investigation of the acoustic anomalies in the Sunda Strait. Hydrophone arrays deployed throughout the region have captured various underwater sounds, including some that contain frequency patterns similar to human vocalizations. However, the interpretation of these recordings remains controversial, with some researchers arguing that the patterns result from data processing artifacts rather than genuine acoustic phenomena. The ongoing geological activity in the Sunda Strait has provided natural laboratories for studying the relationship between volcanic processes and acoustic phenomena. The emergence of Anak Krakatau, a new volcanic island that began forming in the caldera left by the 1883 eruption, has created opportunities to observe how volcanic activity affects the local acoustic environment. Some studies have documented correlations between gas release events and unusual sound patterns, though none have conclusively demonstrated the creation of voice-like sounds. The phantom screams of the Sunda Strait continue to be reported into the modern era, though with decreasing frequency as shipping patterns have changed and the strait has become more heavily trafficked. Contemporary witnesses describe the same basic phenomenon: human-like cries carrying across calm water with no visible source, occurring most often during periods of minimal wind and clear atmospheric conditions. For the families and communities affected by the original Krakatoa disaster, the reports of ongoing screams carry deep emotional significance. Some view them as a form of eternal memorial to those who lost their lives, a reminder that the victims of natural disasters should not be forgotten. Others find the reports disturbing, suggesting that the souls of the dead have not found peace and remain trapped at the site of their traumatic death. The mystery of the Sunda Strait's phantom screams represents a convergence of geological violence, human tragedy, and unexplained acoustic phenomena that challenges our understanding of how the natural world processes and preserves the echoes of catastrophic events. Whether the sounds result from ongoing volcanic activity, atmospheric conditions, psychological factors, or something beyond current scientific understanding, they serve as a haunting reminder of the power of natural forces and the vulnerability of human life in the face of geological catastrophe. As ships continue to navigate the waters where Krakatoa once stood, passengers and crew occasionally report hearing those same phantom cries that have echoed across the strait for more than a century. The screams serve as an audible connection to one of history's greatest natural disasters, a sound bridge spanning the decades between past tragedy and present mystery, reminding us that some events leave marks on the natural world that time alone cannot erase. Story 5. The Screaming Vents of the Mid-Atlantic Ridge. From the volcanic aftermath of the Sunda Strait, we now venture to one of Earth's most dramatic geological features, the Mid-Atlantic Ridge, where the very ocean floor is being torn apart and reborn, in a process that has continued for millions of years. This underwater mountain range, stretching for over 10,000 miles down the center of the Atlantic Ocean, represents the boundary where two massive tectonic plates slowly drift apart, allowing molten rock from the Earth's interior to emerge and create new seafloor. It is here, in the crushing depths where fire meets water, that scientists have encountered some of the most terrifying and inexplicable sounds ever recorded beneath the waves. The Mid-Atlantic Ridge is a geological marvel that demonstrates the raw power of our planet's internal forces. As the North American and Eurasian plates separate in the north, and the South American and African plates diverge in the south, the ridge acts like a massive underwater zipper being slowly pulled apart. The separation occurs at a rate of only a few centimeters per year, but the cumulative effect over geological time has created an underwater landscape of towering peaks, deep valleys, and active volcanic vents that rival anything found on the continents. Along this ridge system, hydrothermal vents create some of the most extreme environments on Earth. These underwater geysers occur where seawater penetrates deep into the ocean floor, becomes superheated by contact with molten rock, and then erupts back into the ocean loaded with minerals and chemicals. The water emerging from these vents can reach temperatures exceeding 750 degrees Fahrenheit, hot enough to melt lead, yet remains liquid due to the crushing pressure of the deep ocean. In 1999, a research expedition was conducting detailed studies of hydrothermal vent systems along a particularly active section of the Mid-Atlantic Ridge, approximately 2,000 miles northeast of Brazil. The expedition was using advanced submersible technology to explore vents at depths exceeding 9,000 feet, where the pressure reaches more than 280 times that at sea level. The mission objectives included studying the unique ecosystems that thrive around these vents and investigating the geological processes that create them. The research submersible, carrying a crew of 3 scientists and a pilot, had been conducting routine observations and sample collection when they encountered a cluster of particularly active hydrothermal vents. These vents were among the most vigorous the team had ever observed, ejecting superheated water and minerals with tremendous force, creating towering plumes that rose hundreds of feet into the water column before dispersing into the surrounding ocean. As the submersible maneuvered closer to document these impressive geological features, the crew began to notice unusual acoustic signatures coming through their hydrophone systems. The sounds were unlike the typical geological noises associated with hydrothermal activity, the rumbling of moving rock, the hiss of escaping gases, or the crack of thermal expansion and contraction. Instead, what they heard sent chills through the cramped cabin of the deep-sea vehicle. The sounds were distinctly voice-like, resembling human screams with a clarity and emotional intensity that was impossible to ignore. The cries seemed to emerge from the vents themselves, as if the superheated water was somehow giving voice to anguish and terror. The frequency and pattern of the sounds closely matched human vocalizations, with rising and falling pitches that conveyed unmistakable distress. Initially, the research team assumed they were experiencing some form of equipment malfunction or acoustic interference. The extreme conditions around hydrothermal vents can affect electronic equipment in unpredictable ways, and false readings are not uncommon in such environments. However, multiple independent acoustic systems were all recording the same sounds, and the clarity of the screaming voices made equipment failure seem increasingly unlikely. As the submersible continued its observations, the screaming sounds intensified, becoming louder and more frequent as they approached the most active vents. The correlation between proximity to the thermal activity and the intensity of the acoustic phenomena was impossible to ignore. It was as if the vents themselves were crying out, their voices growing stronger as the geological violence beneath them increased. The situation took a dangerous turn when the submersible's instruments began detecting sudden changes in the vent activity. The water temperature readings spiked dramatically, indicating that the thermal output of the vents was increasing beyond normal parameters. More concerning were the pressure readings, which showed unstable fluctuations that suggested the possibility of a major eruption or underwater explosion. The decision was made to retreat to a safer distance, but as the submersible began to maneuver away from the vent field, disaster struck. A massive surge of superheated water erupted from one of the largest vents, creating a thermal plume that rose rapidly through the water column. The submersible, caught at the edge of this eruption, was suddenly enveloped in water hot enough to damage its external sensors and threaten the integrity of its pressure hull. Emergency protocols were immediately activated as the crew fought to escape the thermal plume that threatened to destroy their vessel. The submersible's ballast tanks were blown, and maximum power was applied to the thrusters in an attempt to rise above the dangerous thermal layer. For several terrifying minutes, the crew was uncertain whether their vehicle would survive the encounter with the superheated water. During this emergency ascent, the screaming sounds reached a crescendo that was both terrifying and otherworldly. The hydrophone recordings captured what can only be described as a chorus of anguished voices, as if dozens of souls were crying out in unison from the fiery depths. The sounds were so clear and human-like that crew members later described feeling as if they were listening to actual people in distress, despite knowing that no human could survive in such an environment. The submersible eventually escaped the thermal plume and made it safely to the surface, but not without sustaining significant damage to its external equipment. Several sensors had been destroyed by the extreme heat, and the pressure hull showed signs of thermal stress that required extensive inspection before the vehicle could be cleared for further dives. Post-mission analysis of the acoustic recordings revealed data that challenged conventional understanding of hydrothermal vent acoustics. The sounds captured during the incident showed complex frequency patterns and modulations that were remarkably similar to human vocalizations. Spectral analysis revealed harmonic structures characteristic of vocal cords and respiratory systems, despite the fact that the sounds were apparently emerging from geological features in an environment where no air-breathing life could exist. The correlation between the screaming sounds and the thermal activity of the vents suggested several possible explanations. The most straightforward theory proposed that the rapid expansion and contraction of water and rock around the vents might create acoustic phenomena under certain conditions. As superheated water erupted from the seafloor and encountered the cold ocean, the thermal shock could create pressure waves that might be interpreted as sound. More complex geological theories focused on the interaction between escaping gases and the vent structures themselves. Hydrothermal vents release various gases dissolved in the superheated water, including hydrogen sulfide, carbon dioxide, and methane. Under specific pressure and temperature conditions, these gases might create acoustic resonances as they escape through the rocky chimneys that form around active vents. The mineral-rich water emerging from hydrothermal vents contains high concentrations of sulfides, carbonates, and other compounds that precipitate out as the water cools, gradually building the characteristic chimney structures associated with these features. Some researchers suggested that the ongoing process of mineral deposition and dissolution might create acoustic effects as water flows through the increasingly complex internal structure of the vent chimneys. However, these geological explanations struggled to account for the remarkably human-like quality of the recorded sounds. While various natural processes can create acoustic phenomena, the specific frequency patterns and emotional content apparent in the screaming sounds seem to require a more complex explanation than simple thermal expansion or gas release. Alternative theories explored the possibility that unknown forms of life might be responsible for the vocalizations. Hydrothermal vents support unique ecosystems based on chemosynthesis rather than photosynthesis, with organisms that derive energy from the chemical reactions associated with the vent systems. These life forms have evolved to thrive in conditions of extreme temperature, pressure, and chemical toxicity that would instantly kill most other organisms. Some researchers speculated that highly specialized organisms living within the vent systems themselves might have evolved acoustic communication methods adapted to the unique acoustic properties of the hydrothermal environment. The high mineral content and temperature gradients around vents create complex acoustic conditions that might support sophisticated sound-based communication systems, unlike anything found in conventional marine environments. More exotic theories suggested that the extreme conditions around hydrothermal vents might create physical phenomena that current science doesn't fully understand. The combination of intense heat, crushing pressure, and unique chemistry found in these environments represents some of the most extreme conditions on Earth, potentially allowing for acoustic or other physical effects that don't occur in more conventional settings. The screaming vents of the Mid-Atlantic Ridge have continued to attract scientific attention, with several follow-up expeditions attempting to document and understand the acoustic phenomena associated with hydrothermal activity. Advanced hydrophone arrays have been deployed to monitor vent systems over extended periods, capturing a variety of sounds that include both conventional geological noises and more unusual acoustic signatures that resist easy categorization. Recent advances in underwater acoustic analysis have revealed that many hydrothermal vent systems produce complex sound patterns that were previously undetected or misunderstood. Some of these acoustic signatures show patterns that could be interpreted as communication or response to environmental changes, though the source and purpose of these sounds remain largely mysterious. The 1999 encounter at the Mid-Atlantic Ridge has influenced safety protocols for deep-sea research, leading to enhanced monitoring systems for thermal activity and improved emergency procedures for submersible operations near active vents. The incident demonstrated that hydrothermal systems can change rapidly and unpredictably, creating life-threatening conditions for researchers working in these extreme environments. For the scientific team that experienced the screaming vents firsthand, the memory of those otherworldly voices remains vivid and unsettling. They describe the experience as fundamentally changing their perception of hydrothermal systems, transforming what had been purely geological features into something that seemed almost alive, capable of expressing what appeared to be pain or distress through acoustic means. The mystery of the screaming vents represents one of the most compelling examples of how the ocean's most extreme environments can produce phenomena that challenge our scientific understanding. Whether the sounds result from complex geological processes, unknown biological activity, or something beyond current scientific explanation, they remind us that the deep ocean remains a frontier where the impossible might be commonplace. As we continue to explore the hydrothermal systems of the Mid-Atlantic Ridge and other oceanic spreading centers, the screaming vents serve as a haunting reminder that the boundary between the living and non-living worlds might be more fluid than we imagine. In the crushing depths where fire meets water, where life thrives in conditions that seem designed to destroy it, the ocean itself might be finding its voice, crying out from the very heart of our planet with sounds that touch something primal in the human psyche. Story 6. The Wailing Depths of the Puerto Rico Trench. From the fiery screams of the Mid-Atlantic Ridge, we now descend into the deepest waters of the Atlantic Ocean, where the Puerto Rico Trench cuts a massive gash in the seafloor, north of the Caribbean islands. This underwater canyon, plunging to depths exceeding 28,000 feet, represents one of the most geologically complex and dangerous regions in the Atlantic Basin. Here, where the North American plate overrides the Caribbean plate, tectonic forces create an environment of constant upheaval and unpredictable violence. It was in these crushing depths that researchers encountered acoustic phenomena so otherworldly and terrifying that they forced a fundamental reconsideration of what might be possible in the ocean's most extreme environments. The Puerto Rico Trench stretches for over 500 miles along the northern edge of the Caribbean Sea, forming the deepest point in the Atlantic Ocean. Unlike the gradual slopes found in many oceanic basins, the trench plunges precipitously from the relatively shallow Caribbean platform into abyssal depths that remain largely unexplored. The geological forces that created this massive depression continue to operate today, generating frequent earthquakes and creating one of the most seismically active regions in the Western Hemisphere. In 2002, an international research expedition set out to explore the deepest accessible portions of the Puerto Rico Trench, using advanced deep-sea technology to investigate the unique geological and biological systems that might exist in such extreme conditions. The mission represented one of the most ambitious deep-sea exploration efforts ever attempted in the Atlantic, pushing the boundaries of human technology to reach depths that had never been directly observed. The research vessel positioned itself above one of the trench's deepest sections, where multi-beam sonar had revealed a complex underwater landscape of steep walls, unstable sediment flows, and what appeared to be active geological features on the seafloor. The plan called for a series of deep dives, using a state-of-the-art submersible capable of withstanding the crushing pressures found at such extreme depths. As the submersible began its descent toward the 25,000-foot mark, the crew deployed an array of scientific instruments designed to monitor everything from water chemistry to seismic activity. Among these instruments were sensitive hydrophones, intended to record the acoustic environment of the deep trench, capturing any sounds that might provide insight into the geological processes operating at such depths. The descent proceeded normally for several hours, with the submersible passing through the various layers of the ocean column as it approached the trench's deeper regions. The crew noted the expected changes in temperature, pressure, and water chemistry that characterized the transition from the surface ocean to the abyssal depths. Communication with the surface support vessel remained clear, and all systems showed normal operation as they approached their target depth. Then, at approximately 23,000 feet below the surface, the hydrophones began detecting something extraordinary. At first, the sounds were faint and intermittent, barely distinguishable from the background noise of the deep ocean. But as the submersible continued its descent into the trench's deeper reaches, the acoustic signatures became more distinct and increasingly disturbing. The sounds were unlike anything the research team had encountered in previous deep-sea missions. They possessed a haunting, wailing quality that seemed to rise and fall in patterns that defied easy categorization. The frequency range and modulation of the sounds bore an unsettling resemblance to human vocalizations, specifically the kind of anguished crying that might be heard from someone in extreme distress. What made the phenomenon particularly unnerving was its apparent source. The sounds seemed to be emerging from the deepest parts of the trench itself, originating from depths far below the submersible's current position. As the vehicle continued its descent, the wailing grew progressively louder and more complex, developing into what could only be described as a chorus of otherworldly voices crying out from the abyssal depths. The research team initially assumed they were detecting some form of geological noise, perhaps related to sediment movement or gas releases from the unstable seafloor. The Puerto Rico Trench is known for its seismic activity, and the sounds might represent some previously unknown acoustic signature of tectonic processes operating at extreme depths. However, the human-like quality of the vocalizations made this explanation increasingly difficult to accept. As the submersible approached its maximum operational depth, still several thousand feet above the trench's deepest point, the wailing sounds reached an intensity that was both fascinating and deeply unsettling. The hydrophone recordings captured what appeared to be multiple distinct voices, each with its own tonal characteristics and patterns, yet all united in what seemed to be expressions of profound anguish or despair. Then, without warning, disaster struck. The submersible's pressure monitoring systems began registering anomalous readings that indicated a sudden and dramatic change in the water pressure outside the vehicle. The readings were unlike anything in the crew's experience, showing fluctuations that suggested the presence of pressure waves or other disturbances that could pose a serious threat to the vehicle's integrity. Almost simultaneously, multiple other systems began experiencing malfunctions. The ballast control system showed erratic behavior, making it difficult to maintain the submersible's depth and attitude. Communication systems experienced interference that degraded the quality of contact with the surface support vessel. Most critically, the pressure hull itself began showing stress indicators that suggested it was approaching the limits of its design specifications. The wailing sounds, which had been growing steadily louder during the descent, suddenly intensified to levels that were almost overwhelming through the vehicle's audio systems. The sounds seemed to surround the submersible, coming from all directions simultaneously, as if the entire trench was giving voice to some form of collective anguish. Emergency procedures were immediately activated, as the crew fought to stabilize their vehicle and begin an emergency ascent. The pressure anomalies continued to affect the submersible systems, making the ascent far more dangerous and unpredictable than normal deep-sea operations. For several critical minutes, it was unclear whether the vehicle would be able to reach the surface safely. During the harrowing emergency ascent, the wailing sounds followed the submersible upward, gradually diminishing in intensity as the vehicle climbed towards shallower depths. The sounds maintained their human-like quality throughout the ascent, creating the disturbing impression that whatever was generating them was somehow aware of the submersible's presence and responding to its movements. After more than 4 hours of emergency procedures, the submersible finally reached the surface, its crew shaken but alive. However, the vehicle had sustained significant damage from the pressure anomalies encountered in the deep trench. Several external sensors had been crushed or displaced, and the pressure hull showed signs of stress that required extensive inspection and repair before the vehicle could be cleared for further operations. The expedition was immediately suspended, while engineers and safety experts analyzed what had happened during the dive. The pressure anomalies recorded by the submersible's instruments were unlike anything previously documented in deep-sea exploration, showing patterns that suggested the presence of powerful acoustic or pressure waves originating from the trench's deepest regions. Analysis of the hydrophone recordings revealed data that challenged conventional understanding of deep ocean acoustics. The wailing sounds showed complex harmonic structures and emotional inflections that were remarkably similar to human vocalizations. Spectral analysis revealed frequency patterns that closely matched those produced by human vocal apparatus, despite originating from an environment where no air-breathing life could possibly exist. The correlation between the acoustic phenomena and the pressure anomalies suggested that whatever was creating the wailing sounds might also be responsible for the dangerous conditions that threatened the submersible. Some researchers theorized that intense acoustic energy might be capable of creating pressure waves strong enough to affect deep-sea vehicles, particularly in the unique environment of an oceanic trench. Geological explanations for the phenomena focused on the Puerto Rico Trench's complex tectonic setting. The ongoing collision between the North American and Caribbean plates creates conditions of extreme geological stress that might generate acoustic phenomena through various mechanisms. Sediment flows, gas releases, or seismic activity could potentially create sounds that, under certain conditions, might be perceived as human-like vocalizations. The trench's unique bathymetry might also contribute to unusual acoustic effects. The steep walls and complex bottom topography could create acoustic focusing or resonance effects that amplify and distort sounds from various sources. Water movements within the trench's confined environment might generate acoustic phenomena that don't occur in more open oceanic regions. However, these conventional explanations struggled to account for the specific characteristics of the recorded sounds. The emotional content and complex harmonic structures apparent in the wailing suggested something far more sophisticated than simple geological noise. The apparent responsiveness of the sounds to the submersible's presence added another layer of complexity that defied easy explanation. Alternative theories explored the possibility that unknown biological processes might be responsible for the acoustic phenomena. The deepest parts of oceanic trenches remain largely unexplored, and it's possible that unique lifeforms adapted to such extreme conditions might have evolved sophisticated acoustic capabilities. The high pressure and unique chemistry of the deep trench environment might support biological processes that don't occur elsewhere on Earth. More speculative theories suggested that the extreme conditions in the Puerto Rico Trench might create physical phenomena that current science doesn't fully understand. The combination of crushing pressure, tectonic stress, and isolation from surface conditions creates an environment unlike anywhere else on the planet. These conditions might allow for acoustic or other physical effects that challenge our current understanding of physics and biology. The mystery of the Puerto Rico Trench's wailing depths has influenced subsequent deep-sea research efforts, leading to enhanced safety protocols and more sophisticated monitoring systems for extreme depth exploration. Several follow-up expeditions have attempted to return to the area where the sounds were recorded, but the extreme danger and technical challenges involved in reaching such depths have limited these efforts. Recent advances in autonomous underwater vehicle technology have allowed for some limited exploration of the trench's deeper regions without risking human lives. These robotic explorers have captured additional acoustic data from the trench, including recordings that contain similar wailing sounds, though none as extensive or clear as those recorded during the 2002 manned expedition. The ongoing mystery has also sparked increased scientific interest in the acoustic properties of oceanic trenches, leading to more comprehensive studies of how sound behaves in these extreme environments. Researchers have discovered that trenches can act as massive acoustic waveguides, channeling and amplifying sounds in ways that can create complex and sometimes misleading acoustic phenomena. For the research team that experienced the wailing depths firsthand, the memory of those otherworldly sounds remains a defining moment in their scientific careers. They describe the experience as fundamentally changing their understanding of what might be possible in the ocean's most extreme environments, forcing them to confront the possibility that the deepest parts of our planet might harbor phenomena that challenge our scientific paradigms. The Puerto Rico Trench continues to guard its secrets, a reminder that even in our age of advanced technology and scientific understanding, the deepest parts of our oceans remain largely unknown. The wailing voices that echo from its depths might be geological, biological, or something else entirely, but they represent the sound of a frontier that humanity has barely begun to explore. As we push the boundaries of deep-sea exploration and venture into increasingly extreme environments, the wailing depths of the Puerto Rico Trench serve as both an inspiration and a warning. They remind us that the ocean's deepest places might contain wonders and terrors beyond our current imagination. Places where the normal rules of physics and biology might give way to phenomena that exist at the very limits of the possible. Story 7. The Ghostly Wail of the Drake Passage. From the crushing depths of the Puerto Rico Trench, we now sail south to one of the most feared stretches of water on Earth, the Drake Passage, where the Atlantic and Pacific Oceans collide in a perpetual storm of wind and wave between South America and Antarctica. This 500-mile-wide channel, named after the English privateer Sir Francis Drake, has earned a reputation as the roughest sea passage in the world, where waves can tower 60 feet high and winds exceed hurricane force with little warning. But beyond its reputation for claiming ships and lives, the Drake Passage harbors acoustic mysteries that blur the line between natural phenomenon and supernatural occurrence, where the screaming wind carries voices that have no earthly source. The Drake Passage exists as a unique geographic bottleneck, where the waters of three great oceans, the Atlantic, Pacific, and Southern, are forced together in a narrow channel between Cape Horn and the Antarctic Peninsula. This convergence creates the most powerful ocean current system on Earth, the Antarctic Circumpolar Current, which flows unimpeded around the Antarctic continent, carrying more water than any other current system, and generating some of the most extreme weather conditions found anywhere on the planet. Sailors have long regarded the Drake Passage with a mixture of respect and terror. The absence of any significant landmass between South America and Antarctica allows storm systems to build tremendous power as they circle the Southern Ocean, creating waves and winds of extraordinary violence. Ships crossing the passage must contend not only with mountainous seas, but also with sudden weather changes that can transform relatively calm conditions into life-threatening storms within hours. In 2007, a small yacht attempting to round Cape Horn and transit the Drake Passage found itself battling one of the region's notorious gales. The vessel, crewed by experienced blue water sailors familiar with extreme conditions, had been monitoring weather patterns for days before making the crossing attempt. Forecasts suggested a window of relatively moderate conditions, though in the Drake Passage, moderate is a relative term that still involves significant wind and waves. The crossing began under overcast skies with winds of 25 to 30 knots and seas running 8 to 10 feet, challenging but manageable conditions for a well-prepared vessel and crew. The yacht made steady progress southward, following the Great Circle route that would take them across the narrowest part of the passage toward the Antarctic Peninsula. Radio communications with other vessels in the area indicated similar conditions throughout the region, with no immediate weather threats appearing on satellite imagery. As the yacht reached the midpoint of the passage, approximately 250 miles from both South America and Antarctica, the weather began to deteriorate rapidly. Winds increased to 40 knots, with gusts exceeding 50, while wave heights climbed to 15 to 20 feet, with occasional larger sets. The crew secured the vessel for heavy weather and prepared for what appeared to be developing into a full Antarctic gale. It was during this deteriorating weather that the crew first noticed the sounds. Initially, the acoustic phenomena were subtle, barely distinguishable from the roar of wind and the crash of waves against the hull. But as the storm intensified and the yacht was surrounded by the full fury of a Drake Passage gale, the crew began to hear something that chilled them more than the Antarctic wind. Rising above the natural cacophony of the storm came sounds that were unmistakably vocal, wailing cries that seemed to emanate from the sea itself. The sounds were distinctly different from the whistle of wind through rigging or the groaning of the vessel under stress. These were voices, human-like in their emotional content, crying out across the water with an anguish that was both heart-wrenching and terrifying. The crew initially assumed they were hearing distress calls from another vessel caught in the storm. Radio equipment was immediately activated to scan emergency frequencies, and visual searches were conducted despite the limited visibility in the driving rain and spray. However, no emergency transmissions were detected, and radar screens showed no other vessels within range of their position. As the storm reached its peak intensity, with winds exceeding 60 knots and waves climbing to 25 feet or more, the wailing sounds intensified proportionally. The voices seemed to multiply, creating a chorus of anguished cries that rose and fell with the rhythm of the storm itself. The sounds appeared to come from all directions simultaneously, as if the entire ocean was giving voice to some form of collective suffering. What made the phenomenon particularly unsettling was its apparent correlation with the storm's intensity. During periods when the wind temporarily diminished or the waves subsided slightly, the wailing would fade accordingly. When the storm surge returned with renewed fury, the voices would rise again, creating an eerie harmony between the natural violence of the weather and the supernatural quality of the sounds. The crew attempted to record the phenomena using their onboard electronics, but the combination of equipment strain from the storm conditions and the overwhelming background noise made it difficult to capture clear audio evidence. The sounds were most distinct during the brief moments when the wind would suddenly shift or pause, creating temporary acoustic windows where the wailing voices could be heard with startling clarity. As the yacht struggled through the worst of the gale, riding massive waves and being repeatedly knocked down by the force of the wind, the crew reported that the wailing sounds seemed to intensify during the most dangerous moments. When the vessel was being overwhelmed by breaking waves, or when steering became nearly impossible in the chaotic seas, the voices would rise to almost overwhelming levels, as if responding to the life-threatening nature of the conditions. The storm raged for nearly 18 hours before beginning to subside, during which time the crew battled not only the physical challenges of surviving extreme weather, but also the psychological impact of the mysterious voices that seemed to surround them. Several crew members later described feeling as though they were not alone in their struggle, that the voices represented some form of presence or consciousness within the storm itself. As dawn broke and the winds finally began to moderate, the wailing sounds gradually faded, becoming fainter and less frequent as the weather continued to improve. By the time the yacht reached calmer waters on the northern edge of the Drake Passage, the mysterious voices had disappeared entirely, leaving only the normal sounds of wind and wave that characterized this challenging body of water. Post-storm analysis of the acoustic phenomena reported by the yacht crew revealed several possible explanations for the mysterious wailing sounds. The most conventional theory focused on the unique meteorological conditions that exist in the Drake Passage during severe weather. The convergence of multiple air masses and the interaction between polar and maritime weather systems can create complex atmospheric acoustic effects that might be perceived as voice-like sounds. Wind shear and temperature gradients in the storm system could potentially create acoustic ducting effects, where sounds from distant sources are channeled and amplified in ways that make them audible far from their origin. Ice movements from nearby Antarctic glaciers, whale songs, or even sounds from other vessels hundreds of miles away might be transmitted through these atmospheric channels and perceived as mysterious voices. The psychological factors associated with extreme weather survival also provide a framework for understanding the phenomenon. Crews battling life-threatening storms experience high levels of stress and sensory overload that can affect perception and interpretation of acoustic stimuli. The human brain's pattern recognition systems are particularly sensitive to sounds that resemble human speech, and under conditions of extreme stress, these systems might interpret complex wind and wave sounds as voices. However, the specificity and consistency of the crew's reports suggest that purely psychological explanations may be insufficient. Multiple crew members reported nearly identical experiences, and the correlation between the storm's intensity and the wailing sounds was noted by all witnesses. The sounds were described as distinctly different from the normal acoustic environment of a yacht in heavy weather, possessing characteristics that were difficult to attribute to conventional sources. Local maritime folklore provides alternative explanations rooted in the cultural traditions of sailors who have navigated these waters for centuries. The Drake Passage has been the site of numerous shipwrecks and maritime disasters, with thousands of lives lost to its violent conditions over the past several centuries. According to sailor traditions, areas where many ships have been lost can become acoustically haunted, with the voices of lost mariners carried on the wind during storms. Scientific investigation of the Drake Passage's acoustic environment has revealed several unique characteristics that might contribute to unusual sound phenomena. The region's position at the convergence of multiple ocean current systems creates complex underwater topography and water mass interactions that can generate acoustic effects. The presence of icebergs and ice debris from Antarctic glaciers adds another variable that might influence how sound travels through the local marine environment. The extreme weather conditions that characterize the Drake Passage also create unique atmospheric acoustic conditions. The interaction between warm maritime air masses and cold polar air can create temperature inversions and pressure gradients that affect sound propagation in unpredictable ways. These atmospheric effects might amplify, distort, or channel sounds from various sources, potentially creating the complex acoustic environment where mysterious voices might be heard. Marine life in the Drake Passage includes several species known for their vocalizations, including various whale species that migrate through the region. Under certain atmospheric conditions, whale songs or other marine mammal vocalizations might be transmitted through air, as well as water, potentially creating sounds that could be interpreted as human-like voices. The stress of extreme weather might also cause marine animals to vocalize in unusual ways, contributing to the acoustic complexity of the region. The mystery of the Drake Passage's ghostly whales continues to intrigue both sailors and scientists, representing one of the most consistently reported acoustic anomalies in the world's maritime regions. Similar reports have come from other vessels transiting the passage during severe weather, suggesting that the phenomenon is not isolated to a single incident, but represents a recurring characteristic of the region's acoustic environment. Modern weather routing and communication systems have reduced the frequency of vessels encountering extreme weather in the Drake Passage, but those that do continue to report similar acoustic phenomena. The combination of the region's reputation for danger and the persistent reports of mysterious voices has contributed to its status as one of the most psychologically challenging passages for recreational sailors. The Drake Passage serves as a reminder that the ocean's most extreme environments can produce phenomena that challenge our understanding of the natural world. Whether the wailing voices result from complex meteorological processes, psychological factors, or something beyond current scientific explanation, they represent the sound of one of Earth's most violent and untamed frontiers. For those who have heard the ghostly wails of the Drake Passage, the experience becomes a defining moment in their relationship with the sea. The voices serve as a haunting reminder of the ocean's power and unpredictability, echoing across the waters where three great oceans meet in perpetual conflict, carrying with them the stories of all those who have ventured into these waters and faced the ultimate test of seamanship and survival. Story 8. The Phantom Screams of the Ross Sea. From the tempestuous waters of the Drake Passage, we now venture to the bottom of the world, where the Ross Sea spreads its icy embrace along the coast of Antarctica. This vast embayment, larger than France and Spain combined, represents one of the most pristine and extreme marine environments on Earth. Here, where massive ice shelves meet the open ocean and temperatures remain below freezing year-round, scientific expeditions probe the secrets of a world locked in permanent winter. But in 2019, researchers working in these frozen waters encountered acoustic phenomena that would challenge their understanding of what might be possible in the planet's most isolated and hostile marine environment. The Ross Sea occupies a unique position in the Antarctic marine ecosystem, serving as both a barrier and a gateway between the ice-covered continent and the Southern Ocean. Massive ice shelves, some as large as entire countries, extend hundreds of miles from the Antarctic coastline into the sea, creating a complex landscape of floating ice, open water, and seasonal sea ice that shifts and changes with the austral seasons. This environment represents one of the last pristine marine ecosystems on Earth, largely unchanged by human activity and supporting unique communities of life adapted to extreme polar conditions. Emperor penguins breed on the sea ice, massive pods of orcas and other whales migrate through the seasonal ice edge, and the seafloor harbors ancient communities of sponges and other organisms that have remained isolated for millions of years. The 2019 research expedition was part of an international effort to study the impact of climate change on Antarctic marine ecosystems, using advanced underwater survey techniques to document changes in ice coverage, water temperature, and biological communities. The research vessel, specially reinforced for polar operations, carried a crew of scientists and support personnel, equipped with sophisticated instruments for studying both the physical and biological characteristics of the Ross Sea environment. The expedition's mission included deploying deep-sea monitoring equipment through holes cut in the sea ice, allowing researchers to study the underwater environment beneath the frozen surface. This work required careful coordination between ice operations teams and marine scientists, as the constantly shifting ice conditions created both opportunities and dangers for underwater research. On a particularly clear day in the austral summer, when 24-hour sunlight illuminated the pristine ice landscape, the research team was conducting a routine deep-sea survey in waters approximately 1,500 feet deep. The location was several miles from the nearest ice shelf edge, in an area of relatively stable sea ice that provided a secure platform for their operations. The survey work involved lowering sophisticated hydrophone arrays and other acoustic monitoring equipment through access holes in the ice, allowing the team to study the underwater acoustic environment and document any marine life activity in the area. The Ross Sea's extreme isolation and minimal shipping traffic make it an ideal location for studying natural underwater acoustics without human interference. As the monitoring equipment was deployed and began recording ambient sounds from the underwater environment, the research team initially noted the expected acoustic signatures of the polar marine environment: the creaking and groaning of ice under stress, the distant calls of marine mammals, and the subtle sounds of water movement beneath the frozen surface. However, as the monitoring session progressed, the hydrophones began detecting acoustic anomalies that defied easy explanation. Rising from the depths came sounds that bore an unsettling resemblance to human screaming, carrying emotional content and frequency patterns that seemed impossible in an environment where no air-breathing life could survive. The sounds were distinctly different from the vocalizations of known Antarctic marine life. While seals, whales, and other marine mammals produce a variety of calls that can sometimes sound human-like, these acoustic signatures possessed characteristics that were remarkably similar to human distress vocalizations, complete with the rising and falling patterns that convey terror and anguish. What made the phenomenon particularly disturbing was its apparent source. The sounds seemed to be emerging from the deepest parts of the survey area, originating from depths where the crushing pressure and near-freezing temperatures created conditions that would be instantly fatal to any air-breathing organism. Yet the screaming continued, growing more distinct and more numerous as the monitoring session progressed. The research team initially assumed they were detecting some form of equipment malfunction or acoustic interference from their own operations. Antarctic fieldwork is notoriously difficult for electronic equipment, and false readings are common in the extreme cold and electromagnetic conditions found in polar regions. However, multiple independent recording systems were all capturing the same sounds, and the quality of the recordings was too clear to attribute to technical problems. As the team continued their monitoring efforts, the acoustic phenomena intensified, developing into what could only be described as a chorus of anguished voices rising from beneath the ice. The sounds appeared to follow patterns that suggested some form of communication or response, with different voices seeming to answer or echo each other across the underwater environment. The situation took a dangerous turn when the research equipment itself began experiencing malfunctions that correlated with the intensity of the acoustic phenomena. Critical monitoring systems showed anomalous readings, and communication equipment used to maintain contact with team members working on the ice began experiencing interference that made coordination difficult and potentially dangerous. More concerning were the reports from ice operations teams that the sea ice itself seemed to be responding to whatever was happening below. Subtle vibrations and pressure changes were detected through sensitive seismic monitoring equipment, suggesting that the source of the acoustic phenomena might be powerful enough to affect the physical structure of the ice above. The research team found themselves facing a difficult decision as the acoustic phenomena continued to intensify and equipment problems mounted. The sounds had grown so loud and clear that they could be heard through the ice itself, creating an eerie soundtrack to their scientific operations that was both fascinating and deeply unsettling. Emergency protocols were activated when the ice conditions began showing signs of instability that could threaten the safety of personnel working on the surface. Hairline cracks appeared in the ice near the access holes, and instruments detected pressure changes that suggested the possibility of ice movement or fracturing that could trap team members or damage critical equipment. The decision was made to abort the survey operation and evacuate personnel from the ice surface as quickly as possible. As the team worked to retrieve their equipment and evacuate to the research vessel, the screaming sounds reached a crescendo that was audible even through the thick sea ice, creating an otherworldly chorus that seemed to follow their retreat. The emergency evacuation was completed successfully, but not without significant equipment losses, as some monitoring devices had to be abandoned in the rush to ensure personnel safety. The research vessel moved to a safe distance from the survey site, where the crew could observe the ice conditions without risk, while attempting to understand what had occurred. From their new position, the research team continued to monitor the acoustic environment using shipboard hydrophones, documenting the gradual decline of the screaming phenomena as they moved away from the original survey location. The sounds persisted for several hours after the evacuation, before finally fading to undetectable levels, leaving only the normal acoustic background of the Antarctic marine environment. Post-incident analysis of the acoustic recordings revealed data that challenged conventional understanding of polar marine acoustics. The sounds showed complex harmonic structures and emotional inflections that were remarkably similar to human vocalizations, despite originating from an environment where such sounds should be impossible. The correlation between the acoustic phenomena and the equipment failures suggested several possible explanations. Intense acoustic energy might be capable of interfering with sensitive electronic equipment, particularly in the unique electromagnetic environment of the Antarctic region. The combination of extreme cold, geomagnetic effects, and potential acoustic resonance might create conditions where sound waves could affect electronic systems in unexpected ways. Geological theories focused on the unique conditions beneath the Ross Sea ice, where the interaction between floating ice shelves and the seafloor creates complex pressure and temperature gradients that might generate acoustic phenomena through various mechanisms. Ice movements, gas releases from seafloor sediments, or thermal effects from underwater volcanic activity could potentially create sounds that might be perceived as voice-like under certain conditions. The Ross Sea region is geologically active, with underwater volcanic features and active tectonic processes that could contribute to unusual acoustic effects. The movement of massive ice shelves over the seafloor might create pressure changes that could trigger gas releases or other acoustic phenomena, particularly in areas where the ice is under stress from changing temperature conditions. Alternative explanations explored the possibility that unknown biological processes might be responsible for the acoustic phenomena. The Antarctic marine environment includes species that have been isolated for millions of years, potentially evolving unique characteristics and behaviors that don't occur elsewhere on Earth. The extreme conditions beneath the Ross Sea ice might support biological communities with acoustic capabilities that science has not yet discovered. More speculative theories suggested that the extreme conditions in the Antarctic marine environment might create physical phenomena that current science doesn't fully understand. The combination of crushing pressure, near-freezing temperatures, and isolation from normal marine conditions creates an environment that might allow for acoustic or other physical effects that challenge our understanding of what's possible in natural systems. The incident has influenced subsequent Antarctic research operations, leading to enhanced safety protocols and more sophisticated monitoring systems for detecting acoustic anomalies that might indicate dangerous environmental conditions. The potential correlation between the acoustic phenomena and ice instability has particular implications for the safety of personnel working on sea ice platforms. The mystery of the Ross Sea's phantom screams remains an active area of investigation, with several research groups attempting to understand the acoustic properties of the Antarctic marine environment and the potential causes of the unusual phenomena documented during the 2019 expedition. Advanced monitoring networks have been deployed in the region to capture long-term acoustic data that might provide insights into the frequency and characteristics of these events. For the research team that experienced the phenomenon firsthand, the memory of those otherworldly screams rising from beneath the Antarctic ice remains a defining moment in their scientific careers. They describe the experience as fundamentally changing their perception of the polar marine environment, transforming what had seemed like a sterile, frozen wasteland into something that might harbor mysteries beyond current scientific understanding. The Ross Sea continues to guard its secrets beneath layers of ice and in depths where few humans have ventured. The phantom screams that echo from its frozen depths serve as a reminder that even in the most extreme and seemingly lifeless environments on Earth, phenomena exist that challenge our understanding and force us to confront the possibility that the natural world contains mysteries we have yet to discover. As climate change continues to alter the Antarctic environment and expose previously ice-covered regions to human observation, the acoustic mysteries of the Ross Sea might eventually yield their secrets. Until then, they remain a haunting reminder that in the planet's most isolated corners, the impossible might be commonplace, and the screaming voices of the deep might be trying to tell us something about the hidden life of our planet's most extreme environments. Story 9. The Screaming Eels of the Celebes Sea. From the phantom voices echoing across Antarctica's frozen Ross Sea, we now journey to the tropical waters of Southeast Asia, where the Celebes Sea spreads its warm embrace between the volcanic islands of the Philippines, Malaysia, and Indonesia. This remote body of water, far from major shipping lanes and largely unexplored by mainstream marine science, harbors secrets that challenge our understanding of marine behavior and evolution. Here, in 2004, a night diving expedition encountered creatures so bizarre and aggressive that they forced a complete reconsideration of what might lurk in the planet's most isolated underwater ecosystems. The Celebes Sea occupies a unique position in the complex maritime geography of Southeast Asia, surrounded by some of the most volcanically active islands on Earth, and connected to the deeper Pacific Ocean through a series of underwater passages and trenches that remain largely unmapped. This isolation, combined with the region's complex geological history, has created marine ecosystems that harbor species found nowhere else on the planet, many of which have evolved in complete isolation for millions of years. The sea's bathymetry is as complex as its biology, featuring deep basins that plunge to over 15,000 feet, underwater mountain ranges that rise nearly to the surface, and a labyrinth of seamounts and ridges that create a three-dimensional landscape of extraordinary complexity. This underwater topography, combined with unique current patterns and water chemistry influenced by volcanic activity, has created countless ecological niches where evolution has proceeded along pathways unknown in other parts of the world's oceans. The 2004 diving expedition was part of a broader research effort to document the biodiversity of Southeast Asian coral reef systems, focusing particularly on deep water formations that existed beyond the reach of conventional scuba diving. The team was using advanced mixed-gas diving techniques to explore coral walls and underwater caves at depths exceeding 200 feet, well into the realm where sunlight becomes scarce, and the marine ecosystem takes on characteristics more similar to the deep ocean than to typical tropical reefs. The night dive was planned to coincide with the peak activity period for many deep-water species, when creatures that spend their days hiding in caves and crevices emerge to feed in the darkness. Night diving in such remote locations requires exceptional preparation and safety protocols, as rescue operations would be virtually impossible in the event of an emergency. As the diving team descended through the darkness toward their target depth, their powerful underwater lights began to reveal the alien landscape of the deep coral wall. The familiar tropical reef fish of shallower waters gave way to strange creatures adapted to life in the permanent twilight of the deeper ocean. Bizarre fish with oversized eyes and bioluminescent organs, crustaceans unlike anything found in conventional marine biology textbooks, and coral formations that seemed to defy the normal rules of reef ecology. It was at approximately 180 feet that the team first encountered the eels. Initially, the sighting seemed routine, just another species of moray or snake eel adding to the catalog of biodiversity they were documenting. But as their lights illuminated the creatures more clearly, it became apparent that these were unlike any eels previously documented in scientific literature. The eels were enormous, some exceeding 8 feet in length, with muscular bodies and heads that seemed disproportionately large for their species group. Their coloration was unlike any known eel species, featuring intricate patterns of bioluminescent markings that pulsed and shifted in complex rhythms. But it was their behavior that truly set them apart from any known marine life. As the diving lights illuminated the school of eels, the creatures began producing sounds that were captured clearly through the water by the divers' underwater communication equipment. The sounds were high-pitched, penetrating, and unmistakably resembled human screaming. The acoustic patterns showed the rising and falling tones, the emotional inflections, and the harmonic complexity characteristic of human vocalizations. Yet they were coming from creatures that should have been incapable of producing such sounds. The screaming intensified as the eels became more agitated by the presence of the divers. Unlike the typical withdrawal behavior exhibited by most marine life when encountered by humans, these creatures showed signs of aggressive territoriality that escalated rapidly beyond anything the experienced diving team had encountered in their years of underwater exploration. The eels began to organize their behavior in ways that suggested sophisticated coordination and communication. Individual eels would dart toward the divers, retreat, and then return in larger groups, all while maintaining the screaming vocalizations that created an underwater cacophony of sound that was both fascinating and deeply disturbing. The situation took a dangerous turn when the largest eel in the school, a massive specimen that appeared to be leading the group's behavior, launched a direct attack on one of the divers. The creature's speed and aggression were unprecedented, moving through the water with a serpentine fluidity that made it nearly impossible to track or evade. The attack resulted in severe bite wounds to the diver's arm and leg, injuries that immediately began bleeding profusely in the water. The eel's teeth, evolved for grasping and tearing prey, created lacerations that were both deep and difficult to control underwater. The combination of blood loss, depth, and the continued aggressive behavior of the eel school created a life-threatening emergency that required immediate action. Emergency ascent procedures were activated as the team worked to control the injured diver's bleeding while maintaining the careful decompression schedule necessary to avoid potentially fatal decompression sickness. The injured diver required assistance to reach the surface safely, while the remaining team members had to continue monitoring the aggressive eel school to prevent additional attacks during the ascent. The screaming sounds produced by the eels followed the diving team upward, growing fainter but remaining audible until they reached depths of approximately 100 feet. The acoustic phenomena seemed to be some form of long-distance communication or territorial warning, suggesting that the eel's vocalizations might serve purposes beyond simple threat display. Upon reaching the surface, emergency medical procedures were implemented to treat the severe bite wounds, which required immediate evacuation to the nearest medical facility. The injuries were unlike anything typically seen from marine animal encounters, showing evidence of venom or other biochemical effects that complicated the healing process and suggested these creatures possessed adaptations unknown in other eel species. Post-incident analysis of the underwater recordings revealed acoustic signatures that challenged conventional understanding of marine animal communication. The screaming sounds showed complex frequency patterns and harmonic structures that were remarkably similar to human vocalizations, yet they were produced by creatures operating in an environment where such sounds should be physically impossible to generate or transmit effectively. The biochemical analysis of tissue samples from the bite wounds revealed compounds that didn't match any known marine toxins, suggesting that these eels had evolved unique defensive or predatory biochemistry during their isolation in the Celebes Sea's unique environment. The combination of unknown venom and the aggressive group behavior indicated that these creatures represented either an undiscovered species or a known species that had undergone significant evolutionary changes in isolation. Marine biologists studying the incident noted several characteristics that set these eels apart from all known species. Their size exceeded that of any documented eel species in the region. Their bioluminescent capabilities were far more sophisticated than typical deep-water adaptations, and their group behavior showed levels of coordination and communication, typically associated with much more advanced marine species. The acoustic capabilities of the eels raised particularly intriguing questions about the evolution of communication in isolated marine environments. The production of complex vocalizations requires sophisticated anatomical structures and neural systems that are typically associated with marine mammals rather than fish. The development of such capabilities in an eel species would represent a remarkable example of convergent evolution. The Celebes Sea's unique geological and oceanographic conditions might provide the environmental pressures necessary for such extraordinary evolutionary adaptations. The region's volcanic activity creates unique water chemistry conditions, while the complex bathymetry and isolated basins might support populations that have been separated from related species for millions of years. The incident has influenced subsequent marine research in the region, leading to enhanced safety protocols for deep-water diving operations and increased interest in documenting the unique species that might exist in the Celebes Sea's most remote and inaccessible areas. Several follow-up expeditions have attempted to relocate and study the screaming eels, but the vast area and complex underwater topography have made systematic searches extremely challenging. Recent advances in underwater robotics and remote sensing have allowed for some exploration of the deeper regions where the eels were encountered, revealing complex cave systems and underwater formations that might serve as habitats for unknown species. However, the aggressive behavior documented during the original encounter has led to cautious approaches that prioritize remote observation over direct contact. The mystery of the screaming eels has also sparked broader questions about marine biodiversity in isolated oceanic regions. If such dramatically different species can evolve in the relatively small and accessible Celebes Sea, what other unknown creatures might exist in the world's more remote and inaccessible marine environments? For the diving team that encountered these creatures, The experience has become a defining moment that fundamentally changed their understanding of marine biodiversity and the potential for unknown species to exist even in relatively well-studied oceanic regions. The combination of the eel's extraordinary vocalizations, their unprecedented aggressive behavior, and their apparent biochemical uniqueness created an encounter that challenged every assumption about what might be possible in the natural world. The Celebes Sea continues to guard its secrets, a reminder that even in our age of satellite mapping and underwater exploration, the ocean's most remote corners might harbor creatures that evolution has shaped in ways we can barely imagine. The screaming eels serve as living proof that the boundaries between the known and unknown in marine biology remain fluid, and that the next dive into uncharted waters might reveal wonders and terrors that redefine our understanding of life itself. Story 10. The Lost Submersible of the Peru, Chile Trench. From the tropical depths where screaming eels guard their territorial waters, we now venture to one of the most geologically violent regions on Earth, the Peru-Chile Trench, where the ocean floor plunges to depths that challenge the very limits of human exploration. This massive underwater canyon, stretching for over 3,000 miles along the western coast of South America, represents the boundary where the Nazca Plate slides beneath the South American continent in a process that generates some of the most powerful earthquakes and volcanic eruptions on the planet. It was here, in 1976, that a deep-sea research mission encountered forces so mysterious and destructive that they claimed both a cutting-edge submersible and its crew, leaving behind only a haunting audio transmission that continues to defy explanation decades later. The Peru-Chile Trench ranks among the deepest features in the Pacific Ocean, with its deepest point, the Richards Deep, plunging to over 26,000 feet below sea level. This abyss exists at the epicenter of one of the most seismically active regions on Earth, where the constant collision of tectonic plates creates an environment of perpetual geological violence. Underwater avalanches, volcanic eruptions, and massive earthquakes occur with disturbing regularity, making any exploration of the trench's depths an exercise in extreme risk management. The 1976 research expedition was part of an ambitious international effort to understand the geological processes that occur at such extreme depths, using technology that pushed the boundaries of what was possible in deep-sea exploration. The mission represented a significant investment in both cutting-edge engineering and scientific expertise, bringing together researchers from multiple countries in an attempt to unlock the secrets of one of Earth's most inaccessible environments. The research submersible selected for the mission was a marvel of 1970s engineering, designed specifically to withstand the crushing pressures found at abyssal depths. With a titanium pressure sphere capable of protecting its three-person crew at depths exceeding 20,000 feet, the vehicle represented the pinnacle of deep-sea exploration technology. Advanced life support systems, sophisticated scientific instruments, and multiple redundant safety systems were intended to ensure the crew's survival, even in the event of multiple system failures. The mission profile called for a descent to approximately 23,000 feet, where the crew would conduct geological surveys and collect samples from the trench floor. This depth placed them well within the submersible's operational parameters, though it represented one of the deepest crewed missions ever attempted at that time. Communication with the surface support vessel would be maintained through a sophisticated acoustic link designed to function reliably even at extreme depths. The descent began under ideal conditions, with calm surface weather and all submersible systems functioning within normal parameters. Regular communication checks with the surface confirmed that the mission was proceeding according to plan, with the crew reporting normal observations as they passed through the various layers of the ocean column on their way to the abyssal depths. At approximately 15,000 feet, the crew reported their first unusual observation. The water around them seemed to be exhibiting unusual acoustic properties. Sounds that should have been muffled by the immense water pressure appeared to be carrying farther and with greater clarity than expected. The crew noted this anomaly but continued their descent, as the acoustic conditions, while unusual, did not represent an immediate safety threat. As the submersible continued deeper, approaching the 20,000-foot mark, the acoustic anomalies intensified. The crew reported hearing sounds that seemed to originate from the trench depths below them, sounds that bore no resemblance to the typical geological noises associated with underwater seismic activity. These sounds possess characteristics that were difficult to describe through conventional scientific terminology. They seemed organic, almost vocal in their modulation and emotional content. The final normal communication from the submersible came at 22,800 feet, just 200 feet short of their intended maximum depth. The crew reported reaching the trench floor and beginning their scientific survey work, with all systems continuing to function normally despite the extreme environmental conditions. They confirmed visual contact with the seafloor and began deploying sampling equipment according to their mission protocols. Then, without warning, the acoustic communication link transmitted something that would haunt the surface support team for the rest of their lives. Instead of the expected scientific updates or routine system reports, the communication system carried a sound that was unmistakably a human scream, but amplified and distorted in ways that made it almost inhuman in its intensity and duration. The scream lasted for approximately 15 seconds, during which time it was clearly transmitted through the acoustic link with sufficient clarity to determine that it was emanating from inside the submersible itself. The sound possessed characteristics that suggested extreme terror and physical anguish, yet it seemed to be modified or enhanced by some unknown process that gave it an otherworldly quality. Following the transmission of the scream, all communication with the submersible ceased abruptly. Attempts to re-establish contact through multiple communication systems yielded no response, and backup acoustic transponders designed to activate automatically in emergency situations remained silent. The submersible had simply vanished into the depths of the Peru-Chile Trench, taking its crew and its secrets with it. Emergency protocols were activated immediately, though the extreme depth and remote location of the incident made rescue operations virtually impossible. The surface support vessel maintained position over the submersible's last known location, while additional ships and aircraft were dispatched to assist in search operations. However, the technical challenges of conducting rescue operations at depths exceeding 20,000 feet were beyond the capabilities of 1970s technology. Search operations continued for 3 weeks, using every available deep-sea technology to locate the missing submersible. Side-scan sonar, underwater cameras, and other remote sensing equipment scoured the trench floor in the area where the submersible had disappeared. The search area was complicated by the trench's complex topography, which included steep walls, unstable sediment deposits, and ongoing geological activity that could have moved or buried any wreckage. Despite the extensive search efforts, no trace of the submersible was ever found. No debris field, no pressure hull fragments, no emergency beacons, nothing to indicate what had happened to a 30-ton vehicle that had simply vanished in one of the deepest parts of the Pacific Ocean. The complete absence of any physical evidence made the incident one of the most mysterious disappearances in the history of deep-sea exploration. Analysis of the final acoustic transmission revealed disturbing details about the submersible's last moments. The scream that had been transmitted showed acoustic characteristics that suggested it had been modified or processed by some unknown mechanism. The frequency content and harmonic structure indicated that while the sound originated from human vocal cords, it had been altered in ways that conventional acoustic processing could not explain. More puzzling was the transmission pathway itself. The acoustic communication system was designed to carry voice communications and digital data, but it was not configured to transmit the kind of high-intensity audio signal that characterized the final transmission. The fact that such a signal could be transmitted at all suggested that some form of external influence had affected the communication system's normal operation. Geological theories for the submersible's disappearance focused on the unstable nature of the Peru-Chile Trench environment. Underwater landslides, sudden volcanic activity, or massive seismic events could potentially destroy a submersible without leaving recoverable evidence. The trench's steep walls and unconsolidated sediments create conditions where catastrophic geological events can occur with little warning. However, these conventional explanations struggled to account for the nature of the final audio transmission. While geological catastrophes might explain the submersible's disappearance, they could not explain how a human scream could be transmitted through the acoustic communication system with such clarity and unusual characteristics. The suggestion that the crew had time to transmit a distress call but not to deploy emergency systems or attempt an emergency ascent created additional puzzles. More exotic theories explored the possibility that the submersible had encountered something unprecedented in the trench's depths. The Peru-Chile Trench represents one of the least explored environments on Earth, where extreme pressure, temperature gradients, and unique geological conditions might support phenomena that conventional science has yet to recognize or understand. The acoustic anomalies reported by the crew during their descent suggested that the trench environment might possess unusual acoustic properties that could affect both sound transmission and human perception. Some researchers theorized that extreme pressure conditions might create acoustic effects that could influence human consciousness, or even physical reality in ways that current science cannot explain. Alternative theories suggested that the submersible might have encountered unknown forms of life adapted to the extreme conditions found at abyssal depths. While complex life forms are not generally expected to survive at such depths, the unique conditions in oceanic trenches might support evolutionary adaptations that have not been documented elsewhere. An encounter with such life forms might explain both the submersible's disappearance and the unusual characteristics of the final audio transmission. The incident profoundly influenced subsequent deep-sea exploration efforts, leading to enhanced safety protocols and more robust emergency systems for extreme depth missions. The complete loss of communication and the inability to locate any trace of the submersible highlighted the extreme risks associated with pushing the boundaries of human exploration into the ocean's deepest regions. Modern deep-sea exploration has benefited from significant technological advances since 1976, including more sophisticated communication systems, enhanced emergency protocols, and improved search and recovery capabilities. However, the fundamental challenges of operating at extreme depths remain largely unchanged, and the Peru-Chile Trench continues to represent one of the most dangerous environments for deep-sea exploration. The mystery of the lost submersible has also influenced the development of autonomous underwater vehicles capable of exploring dangerous environments without risking human lives. These robotic explorers have revealed much about the trench's geology and biology, but they have not provided any clues about what happened to the missing submersible or its crew. Recent expeditions to the Peru-Chile Trench have documented ongoing geological activity that could easily destroy deep-sea vehicles, including underwater volcanic eruptions, massive landslides, and seismic events that generate acoustic signatures similar to those reported during the 1976 incident. However, none of these natural phenomena adequately explain the specific characteristics of the final audio transmission that marked the submersible's disappearance. For the families of the lost crew members, the absence of any physical evidence or clear explanation for the incident has created a unique form of grief. Without bodies to recover or a definitive understanding of what occurred, closure has remained elusive for more than 4 decades. The haunting final transmission serves as the only remaining connection to their loved ones' final moments. The Peru-Chile Trench continues to challenge human exploration, its depths holding secrets that may never be fully revealed. The lost submersible and its crew have become part of the trench's legacy, a reminder that some frontiers exact a price that cannot be calculated in advance. Their final transmission, that mysterious and terrifying scream from the abyss, echoes still through the annals of deep-sea exploration. A sound that captures both the wonder and the terror of venturing into the unknown depths where human technology meets the limits of the possible. Story 11. The Ghostly Cries of the Scotia Sea. From the crushing depths of the Peru-Chile Trench, where a submersible and its crew vanished with only a scream as their epitaph, we now sail to the tempestuous waters at the bottom of the world, where the Scotia Sea spreads its icy embrace between South America and Antarctica. This remote stretch of the Southern Ocean, named after the ship that first explored it during Ernest Shackleton's legendary expeditions, represents one of the most isolated and challenging maritime environments on Earth. Here, where massive icebergs drift like floating mountains and storms can appear with terrifying suddenness, a yacht crew in 2013 encountered phantom voices that emerged from their radio equipment with no earthly source, leading them into a nightmare of confusion and near disaster that would challenge their understanding of reality itself. The Scotia Sea occupies a unique position in the global ocean system, serving as a critical corridor between the Atlantic and Antarctic waters, where some of the planet's most powerful ocean currents converge and collide. The Antarctic Circumpolar Current, the largest current system on Earth, flows through these waters carrying more than 140 times the flow of all the world's rivers combined. This massive water movement, combined with the region's proximity to the Antarctic ice sheet, creates weather conditions that can shift from merely challenging to life-threatening within hours. The geography of the Scotia Sea is defined by extremes: massive underwater ridges that rise from abyssal depths to near the surface, creating treacherous navigation hazards; dense concentrations of icebergs that can appear suddenly in areas that were clear just hours before; and weather patterns that seem to follow no conventional meteorological rules. For mariners attempting to transit this region, every aspect of the journey requires constant vigilance and preparation for conditions that can overwhelm even the most seaworthy vessels. The 2013 voyage was undertaken by an experienced crew aboard a well-equipped sailing yacht designed specifically for high-latitude sailing. The vessel was built to withstand the extreme conditions found in polar waters, with reinforced hull construction, sophisticated navigation and communication equipment, and emergency systems designed to function in sub-zero temperatures. The crew included veteran sailors who had previously completed passages through some of the world's most challenging waters, making them well prepared for the rigors of Scotia Sea navigation. The passage began under typical Scotia Sea conditions: overcast skies, moderate to fresh winds, and seas running 8 to 12 feet with occasional larger sets. While challenging, these conditions fell within the crew's experience and the yacht's capabilities. Weather routing services had identified a reasonable weather window for the crossing, though in the Scotia Sea, reasonable is always a relative term that can change dramatically without warning. The yacht had been making steady progress across the sea for 2 days, when the weather began to deteriorate more rapidly than forecasts had predicted. Wind speeds increased from 25 knots to over 40 knots within a few hours, while wave heights climbed correspondingly, creating increasingly dangerous conditions for the relatively small vessel. This rapid intensification of weather conditions is characteristic of the Scotia Sea, where the interaction of multiple weather systems can create sudden and severe storms. As the crew prepared the yacht for heavy weather, securing equipment and reducing sail area to maintain control in the increasing winds, they maintained regular radio communications with other vessels in the region, and with maritime authorities monitoring the area. The radio equipment, essential for both safety and navigation in such remote waters, was functioning normally and providing clear communications despite the deteriorating conditions. It was during one of these routine radio checks that the crew first heard the voices. Initially, the sounds were faint and intermittent, barely distinguishable from the static and atmospheric interference common in high-latitude radio communications. But as the storm intensified, and the yacht was increasingly surrounded by the full fury of an Antarctic gale, the voices became clearer and more disturbing. The sounds emerging from the radio equipment were unmistakably human voices, calling out in what appeared to be distress. The voices carried the emotional urgency and desperation characteristic of maritime emergency communications, with clear calls for help and assistance. The crew immediately assumed they were receiving actual distress calls from another vessel caught in the same storm system. Standard maritime protocols were immediately activated. The crew attempted to respond to the distress calls, requesting position information and details about the nature of the emergency. They also contacted maritime rescue coordination centers to report the apparent distress situation and request assistance in coordinating a rescue response. However, despite repeated attempts at communication, the voices did not respond to their calls. More puzzling was the information from maritime authorities, who reported no other vessels in the immediate area and no registered distress calls from the Scotia Sea region. Radar and automatic identification system equipment aboard the yacht, also known as AIS, showed no other vessels within their detection range, which extended for many miles despite the storm conditions. As the storm reached its peak intensity, with winds exceeding 60 knots and waves climbing to 20 to 25 feet, the phantom voices intensified proportionally. The calls for help became more frequent and more urgent, creating an audio environment that was both compelling and deeply disturbing for the crew struggling to maintain control of their vessel in life-threatening conditions. The voices seemed to be coming from multiple sources, as if several different people were calling for help simultaneously. The emotional content of the calls was unmistakable: fear, desperation, and the kind of urgent pleading that occurs when people face imminent death. For experienced sailors familiar with genuine maritime emergencies, the psychological impact of hearing such calls without being able to respond or locate their source was profound. What made the situation particularly unnerving was the apparent proximity of the voices. Unlike distant radio transmissions that fade in and out with atmospheric conditions, these voices seem to be originating from somewhere very close to the yacht, as if the people calling for help were just beyond visual range in the storm-darkened waters. The clarity and volume of the transmissions suggested that the source was within a few miles of their position. The crew conducted extensive visual searches, despite the limited visibility in the storm conditions, scanning the water for any signs of vessels in distress, life rafts, or people in the water. They also deployed emergency signaling devices and maintained continuous radio watches in case the mysterious voices were actually legitimate distress calls that could be answered. However, no visual contacts were made, and the voices continued to resist all attempts at communication. As the yacht fought through the worst of the storm, riding massive waves and being repeatedly knocked down by the force of the wind, the phantom voices seemed to respond to the vessel's distress. During the most dangerous moments, when the yacht was being overwhelmed by breaking waves, or when steering became nearly impossible in the chaotic seas, the calls for help would intensify, as if the mysterious voices were somehow aware of the yacht's struggle. The correlation between the yacht's danger and the intensity of the phantom voices created an atmosphere of supernatural dread that compounded the already extreme stress of surviving a Scotia sea gale. Crew members reported feeling as though they were not alone in their struggle, that the voices represented some form of presence or consciousness that was experiencing the storm alongside them. The storm raged for nearly 20 hours before beginning to subside, during which time the crew battled not only the physical challenges of surviving extreme weather, but also the psychological impact of the mysterious voices that seemed to surround them. The constant calls for help, combined with the impossibility of providing assistance, created a form of psychological torture that several crew members described as more difficult to endure than the physical dangers of the storm itself. As dawn broke and the winds finally began to moderate, the phantom voices gradually faded, becoming fainter and less frequent as the weather continued to improve. By the time the yacht reached calmer waters on the northern edge of the Scotia Sea, the mysterious transmissions had disappeared entirely, leaving only the normal radio traffic and atmospheric noise typical of the region. Post-storm analysis of the incident revealed several possible explanations for the phantom radio voices, though none provided a completely satisfactory answer to the mystery. The most conventional theory focused on atmospheric radio propagation effects common in high-latitude regions, where magnetic field interactions and ionospheric disturbances can create unusual radio propagation conditions. These atmospheric effects can sometimes cause radio signals to travel much farther than normal, potentially allowing the crew to receive transmissions from vessels hundreds or even thousands of miles away. Under certain conditions, these distant signals might appear to be local transmissions, creating the illusion that nearby vessels were in distress when the actual sources were far beyond visual range. However, this explanation struggled to account for the specific characteristics of the phantom voices, particularly their apparent responsiveness to the yacht's condition and their correlation with the storm's intensity. If the voices were simply distant radio transmissions, they would not be expected to show such precise timing in relation to local conditions aboard the yacht. Psychological factors associated with extreme stress and sensory deprivation also provided a framework for understanding the phenomenon. Crews battling life-threatening storms experience high levels of stress and cognitive overload that can affect perception and interpretation of sensory information. The combination of equipment strain, atmospheric interference, and the crew's expectation of distress calls might have caused them to interpret random radio noise as human voices. Local maritime folklore offered alternative explanations rooted in the tragic history of Antarctic exploration and the countless vessels that have been lost in the Southern Ocean over the past 2 centuries. According to these traditions, areas where many ships have been lost can become acoustically haunted, with the voices of lost mariners carried on radio waves during storms, calling out eternal distress signals that can never be answered. The Scotia Sea has indeed been the site of numerous maritime disasters, from early exploration vessels crushed by ice to modern ships overwhelmed by the region's notorious weather conditions. The accumulated tragedy of these losses, according to folklore, might create a form of electromagnetic memory that manifests during conditions similar to those that claimed the original victims. Scientific investigation of radio propagation in the Scotia Sea has revealed several unique characteristics that might contribute to unusual communications phenomena. The region's position at the convergence of multiple ocean current systems creates complex electromagnetic environments, while the proximity to the South Magnetic Pole can cause unusual effects on radio equipment and signal propagation. The presence of large numbers of icebergs and ice debris can also affect radio propagation in unpredictable ways. Ice formations can act as reflectors or conductors for radio signals, potentially creating complex interference patterns that might be interpreted as voice communications. The dynamic nature of the ice environment, with bergs constantly moving and changing, could create shifting patterns of radio reflection that might explain the variable nature of the phantom voices. Modern satellite communication systems have reduced the reliance on traditional radio communications for safety in remote waters, but vessels transiting the Scotia Sea continue to report similar acoustic phenomena during severe weather conditions. The combination of the region's tragic history and its reputation for generating unusual radio effects has contributed to its status as one of the most psychologically challenging passages for recreational sailors. The mystery of the Scotia Sea's ghostly radio voices continues to intrigue both mariners and researchers, representing one of the most consistently reported communications anomalies in the world's most remote waters. Whether the voices result from complex atmospheric effects, psychological factors, or something beyond current scientific understanding, they serve as a haunting reminder of the isolation and danger that characterize navigation in the Southern Ocean. For the crew that experienced the phantom voices during their Scotia Sea passage, the incident became a defining moment that fundamentally changed their relationship with maritime radio communications. They described feeling forever connected to the mysterious voices that called out from the storm, uncertain whether they had encountered a natural phenomenon, a psychological manifestation, or something that exists in the gray area between science and the supernatural that seems to characterize so many experiences in the world's most extreme maritime environments. Story 12. The Phantom Voices of the Coral Sea. From the storm-lashed waters of the Scotia Sea, where phantom voices called out through the radio static of an Antarctic gale, we now sail north to the warm tropical expanse of the Coral Sea, where crystal-clear waters and perfect sailing conditions mask dangers and mysteries as profound as any found in the world's most extreme maritime environments. This vast body of water, stretching between Australia's northeast coast and the island nations of the Pacific, encompasses some of the most pristine coral reef systems on Earth, including the legendary Great Barrier Reef. But in 1996, a sailing expedition crossing these seemingly benign waters encountered radio transmissions that seemed to emerge from the sea itself, leading to navigation failures and equipment malfunctions that nearly resulted in disaster on one of the world's most dangerous coral formations. The Coral Sea represents a unique maritime environment where the beauty of tropical paradise intersects with the hidden dangers of one of the world's most complex underwater landscapes. Beneath its turquoise surface lies a labyrinth of coral reefs, underwater mountains, and deep oceanic trenches that create navigation challenges, requiring constant vigilance and precision. The Great Barrier Reef alone extends for over 1,400 miles, forming the world's largest coral reef system and creating a maze of channels, passages, and shallow areas that can trap unwary vessels. This underwater topography, while spectacular from a biological perspective, creates one of the most technically challenging navigation environments on Earth. Traditional depth charts struggle to capture the three-dimensional complexity of coral formations that can rise from depths of hundreds of feet to within inches of the surface over very short distances. Modern global positioning system, also known as GPS, and electronic charting have improved navigation significantly, but the dynamic nature of coral growth and the effects of storms and bleaching events mean that even the most current charts may not reflect actual conditions. The 1996 sailing expedition was undertaken by an experienced crew aboard a well-equipped yacht designed for extended ocean voyaging. The vessel carried sophisticated navigation and communication equipment considered state-of-the-art for its time, including GPS navigation, radar, and multiple radio systems for both routine communications and emergency use. The crew included sailors with extensive experience in coral reef navigation, making them well prepared for the challenges of coral sea sailing. The voyage was planned as a leisurely exploration of some of the more remote sections of the Great Barrier Reef, following established shipping channels and recommended anchorages to minimize the risk of running aground on uncharted coral formations. The Coral Sea's reputation for sudden weather changes and complex tidal patterns required careful route planning and constant monitoring of conditions, but the crew's experience and preparation seemed adequate for the challenges ahead. The expedition began under ideal conditions: clear skies, moderate southeast trade winds, and excellent visibility that allowed for visual navigation among the outer reef systems. The yacht made steady progress through the well-marked channels, with the crew enjoying the spectacular scenery of pristine coral formations and the abundant marine life that makes the Coral Sea one of the world's premier sailing destinations. For the first several days of the voyage, everything proceeded according to plan. The yacht anchored each evening in protected lagoons or behind reef formations that provided shelter from the trade winds. Communication checks with marine authorities and other vessels in the area confirmed normal conditions throughout the region, with no weather warnings or navigational hazards reported. It was on the fourth day of the expedition, while transiting a particularly remote section of the outer reef, approximately 200 miles from the nearest major port, that the crew first noticed unusual radio transmissions. The sounds began as faint whispers, barely audible above the normal static and atmospheric noise common in tropical radio communications. Initially, these were dismissed as distant commercial radio traffic or interference from nearby shipping. However, as the day progressed and the yacht moved deeper into the maze of coral formations that characterize this section of the reef, the radio transmissions became more distinct and increasingly disturbing. The sounds were unmistakably human voices, speaking in what appeared to be distressed tones, yet the content was largely unintelligible due to distance and atmospheric distortion. The crew attempted to respond to what they assumed were legitimate communications from other vessels in the area. Standard maritime radio protocols were followed, with calls on emergency frequencies and attempts to establish two-way communication with the source of the transmissions. However, despite repeated attempts, the mysterious voices did not respond to their calls, continuing to transmit in patterns that seemed almost conversational, but remained frustratingly unclear. More puzzling was the information from Marine Traffic Control and other vessels in the region. Radio checks with coastal authorities revealed no other vessels registered in the immediate area, and radar screens showed no contacts that could account for the radio transmissions. According to all official sources, the yacht was alone in a section of the Coral Sea that was largely devoid of commercial or recreational traffic. As evening approached and the crew prepared to anchor for the night in what appeared to be a safe lagoon behind a substantial reef formation, the phantom voices intensified significantly. The transmissions became clearer and more frequent, developing into what could only be described as multiple conversations occurring simultaneously across several radio frequencies. The emotional content of the voices was unmistakable: urgency, concern, and what appeared to be navigation-related discussions. The crew could occasionally make out fragments of words that seemed to relate to position reports, weather conditions, and course changes, as if they were overhearing the radio traffic from an invisible fleet of vessels operating in the same area. What made the situation particularly unnerving was the apparent relevance of the phantom communications to the yacht's own navigation situation. As the crew approached their intended anchorage and began the careful process of threading through coral heads in the fading light, the mysterious voices seemed to be discussing similar navigation challenges, with references to reef passages, depth soundings, and anchor selection that mirrored the yacht's own operational concerns. The correlation between the phantom radio traffic and the yacht's activities created an atmosphere of supernatural unease that was compounded by the challenging navigation conditions. Anchoring safely among coral formations requires precise positioning and constant vigilance for changing conditions, and the distraction of the mysterious voices made these already demanding tasks significantly more difficult. As darkness fell and the crew completed their anchoring procedures, the phantom voices reached a level of clarity and intensity that made it impossible to dismiss them as atmospheric interference or distant transmissions. The voices seemed to be coming from multiple sources very close to the yacht's position, as if several other vessels were anchored nearby in the same lagoon, despite the crew's certainty that they were alone. The night passed fitfully, with crew members taking turns monitoring the radio equipment and attempting to make sense of the ongoing transmissions. The voices continued throughout the night, sometimes fading to barely audible whispers, other times rising to levels that seemed to come from just beyond the boat's lights. Sleep was difficult, as the constant chatter created an atmosphere of activity and presence that was impossible to ignore. Dawn brought no relief from the phantom transmissions, and worse, the crew discovered that their navigation equipment was beginning to malfunction in ways that correlated with the intensity of the radio voices. The GPS system showed erratic position readings that placed the yacht in impossible locations, sometimes indicating that they were on dry land or in areas where charts showed only deep water. More critically, the yacht's compass systems began showing significant deviation from known magnetic bearings, making traditional navigation extremely difficult in an environment where precise positioning was essential for safety. The combination of GPS failures and compass deviation created a navigation crisis that threatened to trap the yacht in the coral maze surrounding their anchorage. The crew attempted to use celestial navigation and visual references to determine their position, but the complexity of the coral formations and the similarity of many reef features made this process extremely challenging. Without reliable electronic navigation, determining safe passage routes through the coral maze became a process of careful visual piloting that was both time-consuming and potentially dangerous. As the navigation crisis deepened, the phantom voices seemed to respond to the yacht's distress, with transmissions that appeared to offer navigation assistance and course guidance. The voices provided what sounded like position reports and safe passage recommendations, but following this phantom guidance would have required trusting invisible sources whose reliability could not be verified. The situation reached a critical point when the crew discovered that their primary radio equipment had developed transmission problems that made it impossible to communicate with coastal authorities or other vessels that might provide assistance. They were effectively cut off from outside help, trapped in a coral maze with failing navigation equipment, and surrounded by phantom voices that offered guidance they dared not trust. Emergency procedures were implemented as the crew worked to restore their navigation capabilities, using backup systems and manual techniques. The yacht's backup GPS unit provided intermittent position fixes that suggested they were several miles from their intended location. Though the accuracy of these readings was questionable, given the ongoing equipment malfunctions, visual navigation using charts and careful observation of coral formations eventually allowed the crew to identify their actual position and plot a course toward deeper water where electronic navigation might function more reliably. However, the process of threading through the coral maze with unreliable instruments took most of the day and required extraordinary caution to avoid running aground on uncharted coral heads. As the yacht finally cleared the outer edge of the reef complex and entered deeper water, the phantom radio transmissions gradually faded, becoming fainter and less frequent as the distance from the reef increased. Simultaneously, the navigation equipment began functioning normally again, with GPS and compass systems returning to reliable operation without any apparent technical intervention. By the time the yacht reached the safety of a major shipping channel, the mysterious voices had disappeared entirely, leaving only the normal radio traffic and atmospheric noise typical of the Coral Sea region. The navigation equipment functioned flawlessly for the remainder of the voyage, with no recurrence of the malfunctions that had created such dangerous conditions near the reef. Post-expedition analysis of the incident revealed several possible explanations for the phantom radio transmissions and associated equipment failures, though none provided a completely satisfactory account of all the observed phenomena. The most conventional theory focused on electromagnetic interference from the complex mineral compositions found in coral reef systems, which might affect radio propagation and electronic equipment in unpredictable ways. Coral formations contain various minerals and metals that could potentially create electromagnetic anomalies, particularly in areas where the reef structure extends close to the surface. These effects might be amplified by atmospheric conditions, tidal changes, or solar activity, creating environments where radio and navigation equipment behave erratically. However, this explanation struggled to account for the human-like quality of the phantom transmissions and their apparent responsiveness to the yacht's navigation situation. While electromagnetic interference might explain equipment malfunctions, it could not easily explain the generation of sounds that resembled intelligent conversations about navigation and seamanship. Atmospheric propagation effects provided another potential explanation, suggesting that the crew might have been receiving radio transmissions from vessels hundreds or thousands of miles away, with atmospheric conditions causing these distant signals to appear as local transmissions. The tropical atmosphere above the Coral Sea can create unusual radio propagation conditions that might explain the phantom voices. Alternative theories explored the possibility that the complex underwater topography of the Great Barrier Reef might create acoustic effects that could influence radio equipment and human perception. The interaction between radio waves and the three-dimensional structure of coral formations might create standing wave patterns or resonance effects that could generate unusual audio phenomena. Marine folklore in the region offers explanations rooted in the long history of ships lost on the Great Barrier Reef, one of the world's most dangerous navigation hazards. According to local traditions, areas where many vessels have been wrecked can become electromagnetically haunted, with the radio calls of lost mariners continuing to transmit across the airwaves long after their ships have been claimed by the reef. The Great Barrier Reef has indeed claimed hundreds of vessels over the centuries, from early exploration ships to modern commercial vessels that have fallen victim to its hidden dangers. The accumulated electromagnetic signatures of these disasters, according to folklore, might create a form of radio memory that manifests during conditions similar to those that claimed the original victims. Modern research into the electromagnetic properties of coral reef systems has revealed complex interactions between marine life, mineral formations, and radio frequency energy that are still not fully understood. Some studies have documented unusual radio propagation effects near large reef systems, though none have specifically addressed the generation of voice-like sounds. The incident has influenced safety protocols for sailing in coral reef environments, emphasizing the importance of backup navigation systems and the dangers of relying too heavily on electronic equipment in areas known for electromagnetic anomalies. The correlation between the phantom voices and navigation equipment failures has particular implications for safety planning in remote reef areas where outside assistance may not be readily available. For the crew that experienced the phantom voices of the Coral Sea, the incident remains a defining moment that changed their understanding of the relationship between technology and the natural world. They describe feeling as though they had encountered some form of intelligence or consciousness within the reef system itself, an awareness that responded to their presence and seemed to offer assistance, even as it challenged their reliance on technological navigation aids. The Coral Sea continues to challenge mariners with its combination of natural beauty and hidden dangers, where the line between paradise and peril can be measured in inches of water depth. The phantom voices that emerge from its depths serve as a reminder that even in the most well-charted and frequently traveled waters, mysteries persist that challenge our understanding of the natural world and force us to confront the possibility that the ocean harbors forms of intelligence and awareness that science has yet to recognize or understand. Story 13. The Screaming Reef of the Andaman Sea. From the phantom radio voices that haunt the coral maze of the Great Barrier Reef, we now journey to the tropical waters of the Andaman Sea, where the meeting of the Indian Ocean and the complex archipelagos of Southeast Asia creates a marine environment of extraordinary beauty and hidden danger. This body of water, nestled between the coasts of Thailand, Myanmar, and the Indonesian islands, harbors some of the world's most pristine coral reefs, alongside deep oceanic trenches that plunge to abyssal depths. It was here, in 2008, that a diving expedition encountered acoustic phenomena so disturbing and immediate in their warning that they may have saved lives by alerting divers to imminent geological catastrophe. The Andaman Sea occupies a unique position in the complex tectonic landscape of Southeast Asia, where multiple crustal plates converge in a geological environment of constant upheaval and change. The devastating 2004 Indian Ocean tsunami originated from an undersea earthquake along the Indo-Australian plate boundary that runs through this region, demonstrating the tremendous geological forces that operate beneath the sea's deceptively peaceful surface. This tectonic activity has created a landscape of extraordinary diversity, from shallow coral atolls that barely break the surface to deep trenches that descend to depths exceeding 15,000 feet. The coral reef systems of the Andaman Sea represent some of the most biologically diverse marine ecosystems on Earth, rivaling even the Great Barrier Reef in their complexity and species richness. These reefs have developed over millions of years in the warm, nutrient-rich waters that characterize the tropical Indian Ocean, creating underwater landscapes of breathtaking beauty and incredible fragility. However, the same geological forces that have shaped these reefs continue to operate today, making them dynamic systems where change can occur suddenly and sometimes catastrophically. The 2008 diving expedition was part of a marine biology research project documenting coral reef biodiversity in one of the Andaman Sea's most remote and pristine reef systems. The research team included experienced divers and marine biologists, equipped with sophisticated underwater documentation equipment and safety gear appropriate for diving in challenging tropical conditions. The target reef was located in an area known for its exceptional coral health and diversity, far from the coastal development and tourism impacts that affect many Southeast Asian reef systems. The reef complex consisted of a large underwater mountain that rose from depths exceeding 1,000 feet to within 20 feet of the surface, creating a dramatic underwater landscape of walls, caves, and coral gardens. This topography was typical of many Andaman Sea reefs, where volcanic activity and tectonic uplift have created steep underwater formations that support diverse marine communities at different depth levels. The diving operation was carefully planned to take advantage of optimal conditions: calm seas, excellent visibility, and minimal current that would allow for safe exploration of the reef's more challenging features. The research team intended to conduct multiple dives over several days, systematically documenting the coral species and marine life found at different depths and locations around the reef complex. The first day of diving proceeded according to plan, with the team successfully documenting healthy coral formations and abundant marine life typical of pristine Andaman Sea reefs. Visibility exceeded 100 feet, water temperature was ideal for extended diving, and sea conditions remained calm throughout the day. The team completed 3 successful dives without incident, collecting valuable scientific data and underwater photography. It was on the second day of the expedition, during what was planned to be the deepest and most technically challenging dive of the research project, that the team encountered the acoustic phenomena that would transform a routine scientific mission into a life-threatening emergency. The dive profile called for exploration of the reef's deeper sections at depths approaching 130 feet, where low light conditions and nitrogen narcosis would require careful attention to safety protocols. As the diving team descended along the reef wall, following established safety procedures and maintaining proper group formation, they began to notice unusual sounds emanating from the coral formation itself. The sounds were distinctly different from the normal acoustic environment of a coral reef, which typically includes the crackling sounds of feeding fish, the movement of water through coral structures, and the distant noise of breaking waves above. These new sounds possessed characteristics that were deeply unsettling, high-pitched vocalizations that bore an unmistakable resemblance to human screaming. The sounds seemed to emerge from deep within the coral structure, as if the reef itself was giving voice to some form of distress or warning. The acoustic phenomena were clear enough to be heard through the divers' breathing apparatus and the normal background noise of their life support systems. Initially, the diving team assumed the sounds might be coming from marine life within the reef structure. Some fish species and marine mammals can produce vocalizations that might be perceived as voice-like, particularly when heard underwater, where sound transmission characteristics differ significantly from air. However, the frequency and emotional content of these sounds were unlike any known marine animal vocalizations. As the dive continued and the team moved closer to their target depth along the reef wall, the screaming sounds intensified dramatically. The vocalizations became more frequent and more urgent, developing into what could only be described as cries of alarm or warning. The sounds appeared to be coming from multiple sources within the reef structure, creating an underwater cacophony that was both fascinating and deeply disturbing. The diving team leader made the decision to investigate the source of the sounds more closely, carefully approaching sections of the reef where the vocalizations seemed most intense. Advanced underwater communication equipment allowed the team to discuss their observations while maintaining proper diving safety protocols, though the mysterious sounds made normal underwater communication more difficult. As the divers examined the coral formation more closely, they began to notice subtle signs of structural instability in the reef. Small cracks appeared in some of the larger coral formations, and sediment clouds occasionally drifted from areas where the coral structure seemed to be under stress. These observations were concerning, as they suggested ongoing geological activity that might affect the stability of the entire reef system. The screaming sounds reached a crescendo of intensity just moments before disaster struck. Without warning, a large section of the reef wall began to collapse, sending massive chunks of coral and rock tumbling into the depths below. The collapse occurred directly above the diving team's position, creating an underwater avalanche of debris that posed immediate life-threatening danger to anyone in its path. Emergency ascent procedures were immediately activated, as the diving team worked to escape the danger zone while maintaining the careful decompression schedule necessary to avoid potentially fatal decompression sickness. One team member was struck by falling coral debris, sustaining injuries that required immediate first aid underwater before emergency ascent could be completed safely. The reef collapse created massive sediment clouds that reduced visibility to near zero, making navigation and group coordination extremely difficult during the emergency ascent. The team relied on their training and emergency procedures to maintain contact with each other while ascending through the debris field created by the collapsing reef structure. Upon reaching the surface, emergency medical procedures were implemented to treat the injured diver, whose wounds included lacerations and possible compression injuries from the impact of falling coral. The injuries required immediate evacuation to the nearest medical facility, highlighting the serious nature of the underwater emergency that had developed so suddenly. Analysis of the reef collapse revealed geological processes that had been building pressure within the coral structure for an unknown period of time. The Andaman Sea's position, along active tectonic boundaries, creates ongoing seismic stress that can affect coral reef stability, particularly in areas where the reef structure has grown over unstable geological foundations. The screaming sounds that preceded the collapse appeared to be related to gas releases from within the coral structure as geological pressure built to critical levels. Organic decay processes within coral reefs can generate various gases, and when these gases are released under pressure through cracks and fissures in the coral structure, they can create acoustic phenomena that might be perceived as voice-like sounds. The specific acoustic characteristics that made the sounds resemble human screaming likely resulted from the frequency ranges and pressure dynamics involved in the gas release process. As compressed gases escaped through narrow openings in the coral structure, they created sound patterns that coincidentally matched those produced by human vocal apparatus under stress. However, the remarkable timing of the acoustic warning in relation to the structural collapse raised questions about whether such phenomena might serve as early warning systems for geological instability in coral reef environments. The fact that the screaming sounds intensified immediately before the collapse suggested a direct correlation between the acoustic phenomena and the mechanical stress within the reef structure. Post-incident investigation revealed that the reef area had experienced several minor seismic events in the weeks preceding the dive expedition, creating geological stress that gradually weakened the coral structure until catastrophic failure occurred. The screaming sounds may have been the acoustic signature of this structural deterioration, providing advance warning of the impending collapse. The incident has influenced safety protocols for diving in geologically active coral reef areas, emphasizing the importance of recognizing and responding to acoustic warnings that might indicate structural instability. The correlation between unusual underwater sounds and potential geological hazards has particular relevance for diving operations in the seismically active waters of Southeast Asia. Modern understanding of coral reef geology has revealed that these ecosystems are far more dynamic and potentially unstable than previously recognized. Climate change, ocean acidification, and ongoing geological activity combine to create conditions where coral reef structures can change rapidly and sometimes catastrophically, posing new challenges for diving safety and marine conservation. The acoustic properties of coral reef systems have become an active area of research, with scientists studying how sound travels through these complex biological and geological structures. Some research has suggested that healthy coral reefs produce characteristic acoustic signatures that can be used to monitor ecosystem health, while stressed or damaged reefs may produce different sound patterns that indicate environmental problems. The screaming reef of the Andaman Sea has become a case study in the relationship between geological processes and biological systems, demonstrating how the same forces that create and maintain coral reef ecosystems can also destroy them. The incident highlights the importance of understanding coral reefs as dynamic systems where biological and geological processes interact in complex ways. For the diving team that experienced the screaming reef, the incident served as a profound reminder of the hidden dangers that can exist even in the most beautiful and apparently stable marine environments. The acoustic warning that saved their lives has made them advocates for increased awareness of geological hazards in coral reef diving and the importance of recognizing natural warning signs that might indicate dangerous conditions. The Andaman Sea continues to challenge divers and researchers with its combination of extraordinary beauty and hidden geological violence. The Screaming Reef stands as a testament to the dynamic nature of coral ecosystems and the importance of respecting the powerful forces that operate beneath the surface of even the most pristine tropical waters. In a region where geological change can occur suddenly and catastrophically, the ability to recognize and respond to acoustic warnings might mean the difference between life and death for those who venture beneath the waves. Story 14. The Unexplained Sounds of the Bransfield Strait. From the collapsing coral reefs of the tropical Andaman Sea, we now venture back to the icy waters surrounding Antarctica, where the Bransfield Strait cuts a narrow channel between the Antarctic Peninsula and the South Shetland Islands. This remote waterway, discovered during the early days of Antarctic exploration, represents one of the most geologically active and scientifically fascinating regions in the Southern Ocean. Here, where massive ice shelves meet volcanic islands and tectonic forces reshape the seafloor in real time, a 2020 research expedition encountered acoustic phenomena that seemed to herald geological violence with a precision that challenged scientific understanding of the relationship between sound and seismic activity. The Bransfield Strait occupies a unique position in Antarctic geography, serving as both a barrier and a gateway between the relatively ice-free waters of the Southern Ocean and the heavily glaciated Antarctic Peninsula. This narrow seaway, approximately 100 miles wide at its broadest point, is bounded by some of the most spectacular and volatile geological features in Antarctica. The South Shetland Islands, which form the strait's northern boundary, are the products of ongoing volcanic activity that continues to reshape the region's geography through eruptions, earthquakes, and massive ice movements. The geological processes operating in the Bransfield Strait are driven by the complex interaction between the Antarctic Peninsula's continental crust and the oceanic plates of the South Atlantic. As these massive crustal blocks interact, they create a rift valley environment similar to those found along mid-ocean ridges, but complicated by the presence of thick ice sheets and the extreme environmental conditions that characterize Antarctica. This combination of active tectonics and glacial dynamics creates an environment where geological change occurs at a pace that can be observed in real time. Underwater volcanic eruptions are common, often occurring beneath ice shelves, where they remain hidden from direct observation. Massive icebergs calve from glaciers with such frequency that the Strait's navigation charts require constant updating to reflect changing ice conditions. The 2020 research expedition was part of an international effort to understand how climate change affects Antarctic geological processes, using advanced seismic monitoring equipment to study the relationship between ice loss, volcanic activity, and tectonic movements. The research vessel, specially equipped for polar operations, carried a crew of scientists and technical specialists equipped with state-of-the-art instruments for monitoring both geological and acoustic phenomena in the harsh Antarctic environment. The mission included deployment of sensitive seismic monitoring arrays on the seafloor of the Bransfield Strait, where they would record earthquake activity and volcanic processes over an extended period. These instruments were designed to operate autonomously in the extreme conditions found beneath Antarctic waters, where temperature, pressure, and ice movements create challenges that push monitoring technology to its limits. The research vessel had been conducting routine deployment operations for several days when the scientific team noticed unusual acoustic signatures appearing on their hydrophone arrays. The sounds were initially faint and intermittent, barely distinguishable from the normal background noise of the Antarctic marine environment, the creaking and groaning of ice under stress, the distant calls of marine mammals, and the subtle sounds of water movement beneath the frozen surface. However, as the monitoring session progressed, the acoustic anomalies became more distinct and increasingly unusual. The sounds possessed characteristics that were difficult to categorize using conventional acoustic analysis techniques. They resembled human vocalizations in their frequency range and modulation patterns, yet they appeared to be originating from the seafloor itself, from depths where no air-breathing life could survive. The research team initially assumed they were detecting some form of equipment malfunction or acoustic interference from their own operations. Antarctic fieldwork is notoriously challenging for electronic equipment, and the extreme conditions can cause instruments to behave unpredictably. However, multiple independent recording systems were all capturing the same sounds, and the quality of the recordings was too clear and consistent to attribute to technical problems. As the team continued their monitoring efforts, the acoustic phenomena intensified and began to show patterns that suggested some form of organization or structure. The sounds appeared to occur in sequences that resembled conversation or communication, with different voices seeming to respond to each other across the underwater environment. The emotional content of these sounds was unmistakable: urgency, alarm, and what appeared to be warning calls. What made the situation particularly intriguing was the correlation between the acoustic phenomena and seismic activity in the region. The Bransfield Strait experiences frequent small earthquakes as part of its ongoing geological evolution, and the research team's instruments were designed to detect and measure these seismic events as part of their scientific mission. As the mysterious sounds intensified, the seismic monitoring equipment began detecting increased earthquake activity in the strait. The earthquakes were initially small, registering magnitudes of less than 3.0 on the Richter scale, but they showed a pattern of increasing frequency and intensity that concerned the research team. More puzzling was the apparent temporal relationship between the acoustic phenomena and the seismic events. The screaming sounds seemed to precede each earthquake by several minutes, as if the unknown source of the vocalizations was somehow aware of impending seismic activity and was attempting to provide warning. This correlation was noted across multiple earthquake events, creating a pattern that was too consistent to be dismissed as coincidence. The situation became critical when the seismic monitoring equipment began detecting earthquake activity of increasing magnitude, with events approaching magnitude 4.0 that posed potential dangers to the research vessel and its crew. Earthquakes of this magnitude can trigger underwater landslides, ice movements, and other hazards that could threaten ships operating in the confined waters of the Bransfield Strait. The acoustic phenomena reached a crescendo of intensity just minutes before the largest earthquake of the sequence, a magnitude 4.2 event that generated noticeable shaking aboard the research vessel and triggered emergency protocols for potential tsunami or ice movement hazards. The screaming sounds that preceded this earthquake were so loud and clear that they could be heard through the ship's hull, creating an otherworldly chorus that added to the drama of the seismic event. Emergency procedures were activated as the research team worked to secure their equipment and prepare for potential evacuation if the seismic activity continued to intensify. The Antarctic environment leaves little margin for error when natural disasters occur, as rescue operations are extremely difficult and weather conditions can change rapidly from manageable to life-threatening. Fortunately, the major earthquake marked the peak of the seismic sequence, and subsequent earthquake activity gradually diminished over the following hours. As the seismic activity decreased, the mysterious acoustic phenomena also faded, eventually disappearing entirely as the geological situation stabilized. The correlation between the sounds and the earthquakes remained consistent throughout the event, with the acoustic intensity directly reflecting the level of seismic activity. Post-event analysis of the acoustic recordings revealed data that challenged conventional understanding of how geological processes might generate sound. The vocalizations showed complex harmonic structures and frequency patterns that were remarkably similar to human speech, despite originating from an environment where such sounds should be physically impossible to produce. The temporal correlation between the acoustic phenomena and the earthquake sequence suggested several possible explanations for the mysterious sounds. The most straightforward geological theory proposed that the sounds might be generated by gas releases from seafloor sediments under pressure from tectonic stress. As earthquake activity builds, pressure changes in the seafloor might cause trapped gases to escape through fissures and cracks, potentially creating acoustic effects. The unique acoustic properties of the Bransfield Strait environment might amplify and modify these gas release sounds in ways that make them resemble human vocalizations. The interaction between sound waves and the complex underwater topography of the strait, combined with the acoustic effects of ice cover and temperature gradients, might create acoustic focusing or resonance effects that transform simple pressure releases into complex sound patterns. Alternative theories explored the possibility that the sounds might be related to ice movements associated with seismic activity. The massive ice shelves and glaciers surrounding the Bransfield Strait are sensitive to ground movements, and earthquake activity might trigger ice fracturing or movement that could generate acoustic phenomena. The stress and fracturing of ice under seismic forces might create sounds that, when transmitted through water, could be perceived as voice-like vocalizations. More speculative explanations suggested that the extreme conditions in the Antarctic marine environment might create physical phenomena that current science doesn't fully understand. The combination of extreme cold, unique water chemistry, and intense geological activity might allow for acoustic effects that don't occur in more conventional marine environments. The apparent predictive capability of the acoustic phenomena raise particularly intriguing questions about the relationship between sound and geological processes. If the mysterious sounds were indeed generated by geological stress preceding earthquake activity, they might represent a form of natural early warning system that could be valuable for monitoring seismic hazards in geologically active regions. Modern seismology has documented various precursor phenomena that can occur before major earthquakes, including changes in groundwater levels, animal behavior, and electromagnetic fields. The possibility that acoustic phenomena might also serve as earthquake precursors represents an area of active research interest, particularly in regions where seismic monitoring capabilities are limited by environmental conditions. The incident has influenced subsequent Antarctic research operations, leading to enhanced protocols for monitoring acoustic phenomena during geological studies and improved safety procedures for research operations in seismically active areas. The potential correlation between unusual sounds and impending geological hazards has particular importance for Antarctic research, where the extreme environment makes evacuation and rescue operations extremely challenging. Recent advances in underwater acoustic monitoring have allowed researchers to study the sound environment of the Bransfield Strait in greater detail, revealing a complex acoustic landscape that includes sounds from ice movements, marine life, and geological processes. Some of these sounds show patterns that could be interpreted as communication or response to environmental changes, though the source and purpose of these acoustic signatures remain largely mysterious. The mystery of the Bransfield Strait's unexplained sounds continues to attract scientific attention, with several research groups working to understand the acoustic properties of Antarctic marine environments and their relationship to geological processes. The potential for acoustic monitoring to provide early warning of geological hazards represents a promising area for future research and development. For the research team that experienced the phenomenon firsthand, the acoustic warning system of the Bransfield Strait remains a vivid reminder of how much we still don't understand about the relationship between geological processes and the various forms of energy they release. The experience of hearing what appeared to be voices of warning emerging from the Antarctic seafloor has fundamentally changed their approach to geological monitoring and their appreciation for the complex interactions between Earth, ice, and sea that characterize the Antarctic environment. The Bransfield Strait continues to evolve through ongoing geological processes that reshape its seafloor and coastlines on timescales that can be observed within human lifespans. The mysterious sounds that echo from its depths serve as an acoustic chronicle of these changes, a voice from the Earth itself that speaks in frequencies we are only beginning to learn how to interpret and understand. Story 15. The Fatal Dive of the SS Yongala Wreck. From the icebound waters of Antarctica, where mysterious sounds herald geological upheaval, we now return to the warm tropical waters off Queensland, Australia, where one of the nation's most famous shipwrecks has become both a pilgrimage site for divers and a place where the boundary between the living and the dead seems uncommonly thin. The SS Yongala, lost in a cyclone in 1911 with all 122 souls aboard, rests in 95 feet of water on the Great Barrier Reef, where it has become not just a time capsule of maritime history, but the center of acoustic mysteries that have claimed additional lives in the century since its sinking. The SS Yongala was a passenger and cargo steamer that represented the height of early 20th century maritime technology, a 364-foot vessel built to withstand the challenging conditions of Australia's coastal routes. On March 23, 1911, the ship departed Mackay, Queensland, bound for Townsville with 122 passengers and crew aboard, including a racehorse named Moonshine that was traveling to compete in racing events. The ship was well maintained, commanded by an experienced captain, and equipped with the safety equipment required by maritime regulations of the era. What the ship lacked was radio communication equipment, a relatively new technology that might have provided warning of the massive cyclone that was approaching the Queensland coast. Without the ability to receive weather updates or distress calls, the Yongala sailed directly into one of the most powerful storms in the region's recorded history, vanishing without a trace into the turbulent waters of the Coral Sea. The wreck of the Yongala remained undiscovered for over half a century, becoming one of Australia's most enduring maritime mysteries. Families of the lost passengers and crew had no closure, no bodies to bury, and no understanding of what had happened to their loved ones. The ship had simply sailed into a storm and disappeared, becoming another victim of the sea's capacity to swallow vessels without leaving a trace. In 1958, marine salvage operations finally located the wreck lying upright on a sandy bottom in the waters between Cape Bowling Green and Townsville. The ship was remarkably well preserved, protected by warm tropical waters and transformed into an artificial reef that had become home to an extraordinary variety of marine life. The discovery of the Yongala created immediate interest from both historians and divers, making it one of Australia's premier wreck diving destinations. However, the Yongala's reputation as a diving destination was complicated from the beginning by dangerous conditions that made it accessible only to experienced divers. The wreck lies in open ocean, exposed to strong currents from the East Australian current system that can change direction and intensity without warning. Visibility can range from excellent to near zero depending on conditions, and the depth of 95 feet requires careful attention to decompression procedures and nitrogen narcosis management. More troubling were the reports of acoustic phenomena that began to emerge from divers who visited the wreck. Unlike other shipwrecks that lie in silent testimony to past tragedies, the Yongala seemed to retain an audio connection to its tragic final moments. Divers reported hearing sounds that shouldn't exist in the underwater environment. Voices calling out in distress, the creaking and groaning of a ship under stress, and most disturbing of all, what appeared to be humans screaming transmitted through the water with impossible clarity. The acoustic mysteries of the Yongala wreck first gained widespread attention in the 1970s, when several independent diving expeditions reported similar experiences. Divers would descend to explore the wreck's interior or photograph its abundant marine life, only to be disturbed by sounds that seemed to emanate from the ship itself. The voices were described as urgent and pleading, with emotional content that was unmistakably human despite the impossibility of their source. These reports were initially dismissed by the diving community as nitrogen narcosis-induced hallucinations or psychological manifestations of diving in a location associated with tragic loss of life. Nitrogen narcosis, a condition caused by breathing compressed nitrogen at depth, can cause disorientation, hallucinations, and impaired judgment that might explain reports of phantom voices. The power of suggestion, combined with knowledge of the wreck's tragic history, might predispose divers to interpret normal underwater sounds as something more sinister. However, the consistency and specificity of the reports made simple psychological explanations increasingly difficult to accept. Divers with extensive experience, including professional dive instructors and underwater photographers familiar with the effects of nitrogen narcosis, reported nearly identical acoustic experiences. More significantly, some divers began using underwater recording equipment to document their dives, capturing audio that supported their claims of mysterious voices. The 2003 incident that claimed another life at the Yongala wreck site occurred during what should have been a routine recreational dive by an experienced diver who had visited the wreck multiple times previously. The diver was well qualified for the challenging conditions at the site, with advanced certifications and hundreds of logged dives in similar environments. Weather and sea conditions were within acceptable parameters for Yongala diving, with moderate current and good visibility. The dive proceeded normally through the initial descent and exploration phases, with the diver following established safety protocols for wreck penetration and maintaining proper navigation relative to the current direction. The Yongala's structure is generally considered safe for exploration by qualified divers, with numerous entry and exit points that allow for safe wreck penetration when conditions are suitable. It was during the later stages of the dive, as the diver was exploring the ship's interior compartments, that the acoustic phenomena began. According to the testimony of other divers on the same expedition, the diver reported hearing unusual sounds through the underwater communication system used by the diving group. The sounds were described as humans screaming, clear and urgent, coming from somewhere within the wreck structure. The diver became increasingly agitated by the sounds, describing them as cries for help that seemed to be coming from other parts of the ship. Despite attempts by other team members to calm the situation and complete a normal ascent, the affected diver became fixated on locating the source of the distress calls, abandoning established dive plans and safety protocols in an attempt to reach what appeared to be people in need of rescue. The situation deteriorated rapidly when the diver became separated from the group while pursuing the phantom voices deeper into the wreck structure. The complex interior of the Yongala, while generally safe for experienced divers, contains areas where disorientation can occur easily, particularly when normal diving procedures are abandoned. Navigation within the wreck requires constant attention to entry and exit routes, as the ship's interior can become a confusing maze for divers who lose their reference points. More critically, the diver's departure from the planned dive profile occurred just as current conditions at the wreck site began to change. The East Australian current system that flows past the Yongala can shift direction and intensity rapidly, creating situations where divers who were comfortable with current conditions at the beginning of a dive suddenly find themselves fighting much stronger flows that can exceed their swimming capability. The current change that trapped the diver was particularly severe, with flow rates increasing from manageable levels to dangerous velocities within minutes. This type of rapid current change is a known hazard at the Yongala site, where the wreck's position in open ocean exposes it to the full force of oceanic current systems. Experienced Yongala divers learn to recognize the signs of changing current conditions and adjust their diving plans accordingly. However, the diver's disorientation from pursuing the phantom voices prevented recognition of the deteriorating conditions until it was too late to reach safety. The increased current flow made it impossible to swim back to the dive boat's anchor line, the normal method for completing a safe ascent from the wreck. Alternative ascent procedures, including emergency surface signaling and drift diving techniques, require clear thinking and proper execution that become difficult when a diver is already compromised by disorientation and panic. The emergency that developed as the diver struggled against the current was compounded by the rapid air consumption that occurs when divers exert themselves at depth. Fighting strong currents dramatically increases breathing rates, reducing the time available for problem-solving and emergency procedures. The combination of disorientation, strong current, and diminishing air supply created a fatal sequence of events that overwhelmed the diver's training and experience. Despite immediate search and rescue efforts by other members of the diving expedition, the diver was swept away by the current and lost. The body was later recovered several miles from the wreck site, confirming that the victim had been caught in the current flow and carried into open ocean where survival was impossible. The incident marked another fatality at a wreck site that had already claimed many lives, both in its original sinking and in subsequent diving accidents. Investigation of the incident revealed several factors that contributed to the tragedy, including the rapid current change that created dangerous conditions, and the diver's decision to abandon established safety protocols while pursuing the mysterious sounds. However, the role of the acoustic phenomena in triggering the sequence of events that led to the fatality remained a disturbing element that was difficult to address through conventional diving safety measures. Analysis of underwater recordings made at the Yongala wreck site has revealed various sounds that might be interpreted as voice-like under certain conditions. The wreck structure acts as a resonating chamber that can amplify and modify sounds from multiple sources, including current flow through the ship's openings, marine life activity, and the settling of the ship's structure under the influence of currents and marine growth. The East Australian current system creates complex flow patterns around the wreck that can generate acoustic effects as water moves through the ship's compartments and around its external structure. These water flow sounds, when combined with the acoustic properties of the wreck itself, might create frequency patterns that could be perceived as human vocalizations, particularly by divers experiencing nitrogen narcosis or stress. Marine life associated with the wreck also contributes to its acoustic environment. The Yongala hosts an extraordinary variety of fish species, sea turtles, rays, and other marine animals that use the wreck as shelter and feeding grounds. Some of these species produce vocalizations that, when transmitted through the ship's structure and modified by its acoustic properties, might be perceived as human-like sounds. However, these conventional explanations struggle to account for the emotional content and apparent urgency that characterizes many reports of phantom voices at the wreck site. The correlation between the acoustic phenomena and dangerous incidents suggests that the sounds might serve as some form of warning system, alerting divers to changing conditions or hazards that they might not otherwise notice. Alternative theories explore the possibility that the wreck's tragic history has somehow imprinted itself on the physical structure of the ship, creating a form of acoustic memory that manifests under certain conditions. According to this theory, the ship itself has become a repository for the emotional trauma of its final moments, replaying the distress calls and cries for help that marked its passengers' and crew's last hours. The Yongala wreck continues to attract divers from around the world, drawn by both its historical significance and its reputation as one of Australia's premier wreck diving sites. However, the site's dangerous conditions and acoustic mysteries have led to enhanced safety protocols that emphasize proper training, environmental awareness, and psychological preparation for diving in a location associated with tragedy and loss. Modern diving operations at the Yongala site include briefings about the acoustic phenomena that divers might encounter, preparing them for the possibility of hearing unusual sounds, and emphasizing the importance of maintaining proper diving procedures regardless of acoustic distractions. These briefings have helped reduce the psychological impact of the phantom voices while maintaining respect for the site's historical significance. For the diving community, the fatal 2003 incident at the Yongala wreck serves as a sobering reminder of how psychological factors can contribute to diving accidents, even among experienced divers in familiar environments. The power of acoustic phenomena to trigger dangerous behavior highlights the importance of mental preparation and situational awareness in technical diving environments. The mystery of the Yongala's phantom voices remains an active area of interest for both paranormal researchers and diving safety experts. Whether the sounds result from natural acoustic effects, psychological factors, or something beyond current understanding, they represent a unique hazard that requires special consideration in diving safety planning. The SS Yongala rests in eternal silence on the floor of the Coral Sea, yet paradoxically continues to speak to those who visit its watery grave. The voices that echo from its depths serve as a bridge between past and present, connecting modern divers to the tragedy that claimed 122 lives over a century ago. Whether these voices offer warning, seek rescue, or simply bear witness to a maritime disaster that time cannot erase, they ensure that the Yongala's story continues to be told in the most immediate and haunting way possible. Story 16. The Screaming Fog of the Grand Banks. From the sun-drenched waters above the Yongala wreck, where phantom voices claim modern victims, we now sail north to one of the most treacherous and fog-shrouded waters in the North Atlantic, the Grand Banks of Newfoundland. These shallow fishing grounds, where the cold Labrador Current meets the warm Gulf Stream, have long been both a source of extraordinary marine abundance and a graveyard for vessels caught in the region's notorious fog banks. It was here, in 1982, that fishing crews encountered acoustic phenomena so disorienting and terrifying that they led to navigation errors and the loss of an entire vessel, adding another chapter to the Grand Banks' tragic maritime legacy. The Grand Banks represent one of the most productive fishing grounds in the world, where unique oceanographic conditions have created marine ecosystems of extraordinary richness and diversity. The collision between the cold, nutrient-rich Labrador Current flowing south from the Arctic and the warm Gulf Stream moving north from the Caribbean creates upwelling conditions that bring deep water nutrients to the surface, supporting massive populations of fish that have sustained fishing communities for centuries. However, this same collision of water masses also creates some of the most dangerous navigation conditions found anywhere in the world's oceans. When warm, moisture-laden air from the Gulf Stream encounters the cold water and air of the Labrador Current, the result is the formation of dense fog banks that can reduce visibility to mere feet and persist for days or even weeks at a time. These fog conditions have been responsible for countless maritime disasters, including the most famous shipwreck in history, the Titanic, which struck an iceberg in Grand Banks waters on April 15, 1912. The fog that characterizes the Grand Banks is unlike the gentle mists found in other marine environments. It forms rapidly, often without warning, and can create visual conditions so severe that vessels lose all sense of direction and spatial orientation. Traditional navigation methods become virtually useless, and even modern electronic equipment can be challenged by the unique electromagnetic conditions that exist within these dense fog formations. The 1982 incident occurred during the height of the fishing season, when multiple vessels were working the productive waters of the Grand Banks despite challenging weather conditions. The fishing fleet included both large commercial trawlers and smaller independent boats, all seeking to capitalize on the abundant fish stocks that make the region one of the most important commercial fishing areas in the North Atlantic. Weather conditions at the beginning of the fishing period were typical for the Grand Banks. Overcast skies, moderate winds, and intermittent patches of fog that created challenging but manageable navigation conditions. Experienced fishing crews are accustomed to working in marginal visibility conditions, using radar, global positioning system, also known as GPS, and other electronic aids to maintain position and avoid collisions with other vessels or underwater obstacles. The fog bank that eventually engulfed the fishing fleet formed with the sudden intensity characteristic of Grand Bank's weather phenomena. What began as scattered patches of limited visibility rapidly developed into a dense, uniform fog that reduced visual range to less than 50 feet and created acoustic conditions that significantly affected sound transmission and perception. It was within this fog bank that fishing crews first began to hear the sounds that would transform a routine fishing operation into a nightmare of confusion and disaster. The sounds emerged gradually from the muffled acoustic environment created by the dense fog, beginning as faint whispers that crew members initially dismissed as radio chatter or communications from nearby vessels. However, as the fog thickened and visibility dropped to virtually zero, the sounds became more distinct and increasingly disturbing. The voices were unmistakably human, carrying emotional content that suggested distress and urgent need for assistance. The calls seemed to come from multiple directions simultaneously, creating an acoustic environment where it was impossible to determine the location or distance of the apparent sources. The fishing crews immediately assumed they were hearing legitimate distress calls from vessels in trouble within the fog bank. Standard maritime protocols were activated, with boats attempting to respond to the apparent emergency calls and coordinate rescue efforts despite the impossible visibility conditions. Radio communications were used to establish contact with other vessels and coordinate search patterns for locating boats that might be in distress. However, attempts to communicate with the sources of the distress calls proved fruitless. Despite repeated calls on emergency frequencies and standard fishing fleet communications channels, the mysterious voices did not respond to attempts at two-way communication. The sounds continued to transmit what appeared to be calls for help, but they remained frustratingly one-way communications that could not be answered or verified. More puzzling was the information from other vessels in the fleet, many of which reported hearing the same distress calls but from different directions and distances. Radio checks revealed that all documented vessels in the area were accounted for and reporting normal operations, yet the calls for help continued to echo through the fog with increasing intensity and urgency. The acoustic phenomena created a situation of extreme confusion and disorientation among the fishing fleet. Vessels began maneuvering to respond to apparent emergencies that could not be located or verified, leading to dangerous close encounters between boats operating in zero visibility conditions. The combination of acoustic confusion and impossible navigation conditions created a recipe for disaster that tested the skill and experience of even veteran fishing crews. The situation reached a critical point when one fishing vessel, responding to what its crew believed were nearby distress calls, changed course to attempt a rescue operation. The vessel's captain reported hearing clear calls for help that seemed to be coming from very close range, suggesting that another boat was in immediate danger and required assistance. Standard rescue protocols were activated, with the vessel using radar and sound signals to attempt to locate the apparent emergency. However, the course change required to respond to the phantom distress calls took the vessel away from safe navigation routes and into an area of the Grand Banks known for underwater obstacles and variable depths. The combination of fog-induced disorientation and the acoustic confusion created by the mysterious voices led to navigation errors that placed the vessel in increasingly dangerous waters. The fishing boat ran aground on an underwater obstruction while attempting to reach the source of the distress calls, creating a genuine emergency that required immediate response from other vessels in the fleet. The grounding occurred with sufficient force to cause structural damage and flooding that made the vessel unseaworthy, requiring emergency evacuation of the crew before the boat was lost entirely. Rescue operations were complicated by the continuing fog conditions and the ongoing acoustic phenomena that had contributed to the original disaster. Other vessels in the fleet struggled to locate and assist the grounded boat, while continuing to hear the mysterious distress calls that seemed to mock their real emergency efforts. The acoustic confusion made coordination of rescue operations significantly more difficult and dangerous than would normally be the case. The fishing vessel was ultimately lost, becoming another casualty of the Grand Banks' notorious conditions. However, the crew was successfully evacuated without loss of life, preventing the incident from becoming a complete tragedy. The vessel's loss was attributed to navigation error caused by disorientation in fog conditions, but the role of the acoustic phenomena in triggering the disaster remained a controversial aspect of the incident. Investigation of the acoustic effects reported during the incident revealed several possible explanations for the phantom distress calls heard throughout the fishing fleet. The unique atmospheric conditions within dense fog banks can create unusual sound propagation effects that might cause normal radio transmissions or vessel sounds to be perceived as distress calls. Fog formations act as acoustic lenses that can focus, amplify, and distort sound waves in unpredictable ways. Radio transmissions that would normally be directional and clearly sourced might be scattered and reflected by the dense water droplets in the fog, creating the illusion that sounds are coming from multiple locations simultaneously. This acoustic scattering might explain why the phantom voices seem to originate from various directions and distances. The psychological factors associated with navigation in zero visibility conditions also contribute to acoustic confusion and misperception. Crews operating in dangerous fog conditions experience high levels of stress and sensory deprivation that can affect their interpretation of audio stimuli. The expectation of emergency situations and the heightened awareness of danger might cause experienced mariners to interpret routine sounds as distress calls. However, the consistency of reports from multiple independent vessels and the specific characteristics of the phantom voices made purely psychological explanations difficult to accept. The emotional content and apparent urgency of the sounds suggested acoustic sources that were more complex than simple radio interference or stress-induced hallucinations. Local maritime folklore provides alternative explanations rooted in the tragic history of the Grand Banks, where thousands of vessels and tens of thousands of lives have been lost over centuries of fishing and shipping operations. According to these traditions, the fog itself becomes a repository for the final calls of lost mariners, preserving their distress signals in an acoustic form that manifests during conditions similar to those that claimed the original victims. The Grand Banks fog has indeed been present during many of the region's most famous maritime disasters, from the Titanic to countless fishing vessels that have vanished without trace in the region's dangerous waters. The accumulated electromagnetic and acoustic signatures of these tragedies, according to folklore, might create a form of audio memory that replays during foggy conditions when atmospheric effects enhance the transmission of these ghostly signals. Modern research into the acoustic properties of fog formations has revealed complex interactions between sound waves and atmospheric moisture that can create unusual propagation effects. Dense fog can act as both a conductor and an insulator for different sound frequencies, potentially creating conditions where specific types of audio signals are enhanced while others are suppressed. The electromagnetic environment within fog banks also differs significantly from clear atmospheric conditions, with the suspended water droplets creating conditions that can affect radio equipment and electronic navigation systems in unpredictable ways. These electromagnetic effects might contribute to the generation or perception of phantom audio signals that could be interpreted as distress calls. The incident has influenced safety protocols for fishing operations in fog-prone areas like the Grand Banks, emphasizing the importance of maintaining position awareness and avoiding course changes based on unverified audio information. Modern fishing fleets operating in these waters are equipped with more sophisticated navigation and communication equipment that is less susceptible to fog-related interference, though the basic challenges of operating in zero visibility conditions remain unchanged. The mystery of the Grand Banks screaming fog continues to challenge both mariners and researchers, representing one of the most consistently reported acoustic anomalies in North Atlantic waters. Whether the phantom voices result from atmospheric acoustic effects, electromagnetic interference, or something beyond current scientific understanding, they serve as a reminder of the hidden dangers that persist in even well-traveled fishing grounds. For fishing crews who work the Grand Banks, the screaming fog has become part of the occupational hazards they must navigate alongside dangerous weather, equipment failures, and market uncertainties. The voices that call through the mist serve as an audible connection to the thousands of mariners who have worked these waters before them, including those who never returned home to tell their stories. The Grand Banks remain one of the world's most important fishing grounds, despite the dangers posed by fog, ice, and severe weather conditions. The phantom voices that echo through the fog banks serve as eternal warnings about the sea's capacity to confuse and disorient even the most experienced mariners, reminding us that in the dense mists of the North Atlantic, the line between the living and the lost can become as obscured as the horizon itself. Story 17. The Crying Rocks of the Azores. From the fog-shrouded fishing grounds of the Grand Banks, where phantom voices led to maritime disaster, we now venture to the volcanic islands of the Azores, where Portuguese explorers first charted a course through waters that would prove to be among the most geologically active and acoustically mysterious in the Atlantic Ocean. This archipelago, rising from the depths of the mid-Atlantic ridge like a necklace of emerald jewels, harbors beneath its crystal-clear waters a world of volcanic violence that continues to reshape the seafloor in real time. It was here, in 2010, that divers encountered rocks that seemed to weep and scream with human voices, sounds that served as harbingers of underwater eruptions that nearly claimed their lives. The Azores archipelago occupies a unique position in global geology, sitting directly atop the mid-Atlantic ridge, where the Eurasian and North American tectonic plates slowly diverge, allowing molten rock from Earth's interior to rise and create new oceanic crust. This ongoing process of creation and destruction has given birth to 9 major islands and countless underwater volcanic features that make the region one of the most seismically active areas in the Atlantic Basin. The volcanic nature of the Azores is evident everywhere, from the dramatic landscapes of crater lakes and volcanic peaks to the thermal springs that dot the island's coastlines. But it is beneath the waves that the archipelago's volcanic character is most dramatically displayed, with underwater volcanic vents, gas seeps, and active lava flows creating a dynamic and constantly changing marine environment that challenges both scientific understanding and diving safety. The underwater topography around the Azores is characterized by steep volcanic slopes that plunge from near-surface depths to abyssal trenches, creating dramatic underwater landscapes of extraordinary beauty and danger. Volcanic rock formations, sculpted by centuries of underwater eruptions and chemical processes, form complex cave systems and archways that attract divers from around the world. Despite the inherent risks of exploring an actively volcanic marine environment, the 2010 diving expedition was part of a marine geology research project investigating the relationship between underwater volcanic activity and marine ecosystem development in the Azores region. The research team included experienced technical divers and marine geologists equipped with sophisticated underwater documentation equipment and gas monitoring devices capable of detecting changes in water chemistry that might indicate volcanic activity. The target dive site was located on the underwater slopes of a submarine volcano that had shown signs of increased activity in recent months, including elevated water temperatures, changes in marine life distribution, and minor seismic events that suggested ongoing geological processes beneath the seafloor. The site offered an opportunity to study active volcanic processes in a relatively accessible diving environment, though safety protocols reflected the inherent dangers of working near active volcanic systems. The diving operation was carefully planned to minimize exposure to volcanic hazards while maximizing scientific observation opportunities. Advanced mixed-gas diving techniques allowed the team to work at depths where volcanic activity was most evident, while specialized equipment provided real-time monitoring of water temperature, chemical composition, and gas concentrations that might indicate dangerous changes in volcanic activity. The initial descent revealed underwater landscapes of stunning beauty and obvious volcanic origin. Massive rock formations, sculpted by underwater lava flows and chemical processes, created complex three-dimensional structures that supported diverse marine communities adapted to the unique conditions found near active volcanic systems. The water was exceptionally clear, allowing for excellent visibility of the volcanic terrain and its associated marine life. As the diving team approached their target depth and began systematic exploration of the volcanic rock formations, they began to notice unusual acoustic phenomena emanating from the structures themselves. The sounds were distinctly different from the normal underwater acoustic environment, which typically includes the movement of water through rock formations, the activity of marine life, and the distant noise of surface conditions. These new sounds possessed characteristics that were deeply unsettling. They resembled human crying and wailing, with emotional inflections and frequency patterns that were unmistakably voice-like. The sound seemed to emerge from deep within the volcanic rock structures, as if the stone itself was giving voice to some form of anguish or distress. Initially, the diving team assumed the sounds might be related to gas releases from the volcanic formations, a common phenomenon in volcanically active areas where various gases escape from underground chambers through cracks and fissures in the rock. However, the human-like quality of the vocalizations made this explanation increasingly difficult to accept as the sounds became more distinct and emotionally compelling. The crying sounds intensified as the divers moved closer to the most geologically active areas of the volcanic formation, where water temperature readings indicated the presence of thermal vents and ongoing volcanic processes. Specialized gas monitoring equipment detected elevated levels of hydrogen sulfide, carbon dioxide, and other volcanic gases, confirming that active geological processes were occurring within the rock structure. What made the acoustic phenomena particularly disturbing was their apparent responsiveness to the divers' presence and activities. As the team approached certain areas of the rock formation, the crying sounds would intensify, as if the volcanic structure was somehow aware of their presence and responding with increased vocal activity. This apparent interaction between the divers and the acoustic phenomena created an atmosphere of supernatural unease that complicated the scientific objectives of the mission. The situation became critical when the gas monitoring equipment began detecting dangerous increases in toxic gas concentrations that posed immediate threats to the diving team's safety. Hydrogen sulfide levels spiked to concentrations that could be fatal, even with diving equipment, while water temperatures increased dramatically as underwater thermal vents became more active. The crying sounds reached a crescendo of intensity just moments before the underwater volcanic activity escalated to dangerous levels. Multiple thermal vents began releasing superheated water and toxic gases with such violence that the surrounding marine environment became immediately life-threatening for the diving team. The acoustic phenomena seemed to serve as a warning system, alerting the divers to impending volcanic hazards through sounds that were impossible to ignore. Emergency ascent procedures were activated as the team worked to escape the increasingly dangerous volcanic environment while maintaining proper decompression protocols. The combination of toxic gas exposure, extreme water temperature variations, and the need for controlled ascent created a complex emergency that required precise execution of technical diving procedures under extremely challenging conditions. The ascent was complicated by ongoing volcanic activity that continued to release toxic gases and superheated water throughout the water column, requiring the diving team to navigate through hazardous conditions while monitoring their own gas exposure and decompression requirements. The crying sounds continued throughout the emergency ascent, gradually fading as the team moved away from the most active volcanic areas. Upon reaching the surface, emergency medical procedures were implemented to treat potential gas exposure and thermal injuries sustained during the underwater volcanic event. While no serious injuries occurred, the incident highlighted the extreme dangers associated with diving in active volcanic environments and the importance of early warning systems for detecting hazardous changes in geological activity. Post-incident analysis revealed that the crying sounds had indeed been generated by gas releases from the volcanic rock formations, as pressurized gases escaped through narrow openings in the volcanic structure. The specific acoustic characteristics that made the sounds resemble human vocalizations resulted from the pressure dynamics and resonance effects created as gases moved through the complex internal structure of the volcanic formation. The emotional quality of the sounds was a consequence of the frequency ranges and modulation patterns produced by the gas release process, which coincidentally matched those associated with human vocal expressions of distress. The apparent responsiveness of the sounds to the divers' presence was actually a reflection of their proximity to gas release points that became more active as thermal conditions changed throughout the diving operation. However, the remarkable timing of the acoustic warning in relation to the escalation of volcanic activity suggested that such phenomena might serve as natural early warning systems for geological hazards. The crying sounds had provided several minutes of advance notice before the volcanic activity reached dangerous levels, potentially saving the diving team from serious injury or death. The correlation between the acoustic phenomena and volcanic activity has implications for volcanic monitoring and hazard assessment in underwater environments. Traditional volcanic monitoring relies on seismic instruments and chemical sensors that may not provide the immediate, obvious warnings represented by acoustic phenomena that can be perceived directly by humans working in the environment. The incident has influenced safety protocols for diving in volcanically active areas, emphasizing the importance of recognizing and responding to acoustic warnings that might indicate changing geological conditions. The potential for underwater volcanic formations to provide audible warnings of increased activity represents a promising area for further research and development of volcanic hazard monitoring systems. Modern understanding of underwater volcanic processes has revealed that gas releases are common in active volcanic areas, where various gases generated by volcanic activity escape through fissures and vents in the seafloor. The acoustic signatures of these gas releases can vary dramatically depending on the pressure, volume, and chemical composition of the escaping gases, as well as the physical characteristics of the release pathways. The crying rocks of the Azores have become a case study in the relationship between geological processes and acoustic phenomena, demonstrating how natural warning systems might exist in environments where human technology is challenged by extreme conditions. The incident illustrates the importance of understanding and respecting the acoustic language of the Earth itself, particularly in regions where geological violence can emerge with little warning. For the diving team that experienced the crying rocks, the incident served as a profound reminder of the power and unpredictability of volcanic forces, even in areas that appear stable and safe. The acoustic warning that saved their lives has made them advocates for increased awareness of geological hazards in underwater volcanic environments, and the importance of recognizing natural warning signs that might indicate dangerous conditions. The Azores continue to evolve through ongoing volcanic processes that create new land while destroying old formations, making the archipelago a natural laboratory for studying active geological processes. The crying rocks serve as a reminder that in volcanically active regions, the Earth itself might be trying to communicate with us through acoustic signals that we are only beginning to understand and appreciate. As volcanic activity continues to shape the underwater landscapes of the Azores, the crying rocks stand as monuments to the Earth's capacity for both creation and destruction, their voices serving as eternal warnings about the power that lies beneath the seemingly peaceful surface of the Atlantic Ocean. In this region where fire meets water in an ongoing dance of geological violence, the ability to hear and interpret the Earth's acoustic warnings might mean the difference between scientific discovery and tragedy. Story 18. The Screaming Currents of the Agulhas Current. From the volcanic warning voices of the Azores, where crying rocks herald geological violence, we conclude our journey through the screaming ocean with one final tale from the waters off South Africa, where the mighty Agulhas Current creates some of the most dangerous maritime conditions in the world. This powerful western boundary current, flowing southward along Africa's east coast at speeds that can exceed 5 knots, represents one of the fastest and most unpredictable ocean currents on Earth. When it encounters opposing winds and swells from the Southern Ocean, the result is a maritime battlefield, where even large ships can be overwhelmed by waves that appear without warning. It was in these turbulent waters, in 1995, that a fishing vessel encountered acoustic phenomena that seemed to herald the very oceanographic violence that would claim both boat and crew. The Agulhas Current system is one of the most powerful and complex ocean currents on the planet, transporting more than 70 million cubic meters of water per second along the southern African coast. This massive flow of warm, saline water from the Indian Ocean creates unique oceanographic conditions that can change from navigable to deadly within minutes, particularly when the current encounters opposing weather systems, moving up from the Southern Ocean. The current's power lies not just in its speed and volume, but in its interaction with the complex bathymetry of the South African continental shelf. As the current flows over underwater ridges, valleys, and the edge of the continental shelf, it creates standing waves, turbulent eddies, and sudden depth changes that can generate wave conditions capable of overwhelming vessels that moments before were navigating in relatively calm seas. This phenomenon, known as the Agulhas Current retroflexion, occurs when the current meets opposing winds and swells, creating a collision between water masses that generates some of the largest and most dangerous waves found anywhere in the world's oceans. Ships transiting this region must constantly monitor weather and current conditions, as the interaction between the current and adverse weather can create survival conditions that challenge even the largest and most seaworthy vessels. The 1995 incident involved a commercial fishing vessel operating in waters approximately 100 miles southeast of Cape Town, where the Agulhas Current reaches some of its highest velocities, before beginning its eastward turn into the Southern Ocean. The fishing boat was well equipped for the challenging conditions, common in South African waters, with experienced crew members familiar with the Agulhas Current's reputation for creating dangerous sea conditions without warning. Weather forecasts at the time of the incident indicated moderate conditions, with winds of 20 to 25 knots and seas running 8 to 12 feet. Challenging but manageable for a vessel of the fishing boat's size and capabilities. However, weather predictions in the Agulhas current region are notoriously unreliable due to the rapid changes that can occur when current and weather systems interact in unexpected ways. The fishing operation had been proceeding normally for several hours when crew members began to notice unusual sounds that seemed to emanate from the water itself. The sounds were distinctly different from the normal acoustic environment of a working fishing vessel, which includes engine noise, equipment operation, and the natural sounds of wind and wave action against the hull. These new sounds possessed characteristics that were deeply unsettling. They resembled human screaming with an intensity and emotional content that was impossible to ignore. The sounds seemed to come from the water surrounding the vessel, as if the ocean itself was giving voice to some form of distress or warning. The frequency and pattern of the vocalizations closely matched those produced by humans under extreme stress, yet they appeared to be originating from the marine environment. The fishing crew initially assumed they were hearing distress calls from another vessel in the area, possibly transmitted through the water in ways that made their source difficult to determine. Radio checks were immediately conducted to scan for emergency transmissions and verify the status of other vessels operating in the region. However, no distress signals were detected on any emergency frequencies, and coastal authorities reported no other vessels in the immediate area. More puzzling was the apparent source of the screaming sounds, which seemed to be coming from the water itself, rather than from any identifiable external source. The sounds appeared to surround the fishing vessel, creating an acoustic environment where it was impossible to determine direction or distance to the apparent source of the vocalizations. This omnidirectional quality made the phenomenon particularly unsettling for the crew, who had no reference point for understanding what they were experiencing. As the morning progressed and the fishing operation continued, the screaming sounds intensified in both frequency and emotional urgency. What had begun as occasional, barely audible vocalizations developed into a continuous chorus of what could only be described as cries of alarm and warning. The sounds possessed a quality that seemed to penetrate not just the air, but the consciousness of everyone aboard the vessel, creating an atmosphere of supernatural dread that interfered with normal fishing operations. The crew's growing unease was compounded by subtle changes in the marine environment that suggested shifting oceanographic conditions. Water color began to change from the normal blue-green of deep ocean water to a more turbulent gray-green that indicated the presence of suspended sediment and turbulent mixing. Sea surface temperature readings showed unusual fluctuations that suggested the interaction of different water masses, a common precursor to dangerous wave conditions in the Agulhas current region. More concerning were the observations from experienced crew members who noticed changes in wave patterns that indicated the possible development of dangerous sea conditions. The regular, predictable wave trains that had characterized the morning's conditions began to show signs of interference patterns and irregular spacing that suggested the presence of opposing current and wind systems. The screaming sounds reached a crescendo of intensity, just as the oceanographic conditions began to deteriorate rapidly. Within minutes, the moderate sea conditions that had existed throughout the morning were transformed into a chaotic environment of massive, irregular waves that appeared to come from multiple directions simultaneously. The Agulhas current had encountered a weather system moving up from the Southern Ocean, creating the deadly interaction that makes these waters so feared by mariners. The waves that began to assault the fishing vessel were unlike anything in the crew's experience, despite their familiarity with challenging South African sea conditions. Individual waves reached heights exceeding 40 feet, but more dangerous was their steepness and unpredictability. These were not the long, rolling swells that experienced mariners can navigate safely, but sharp, breaking waves that struck with the force of moving walls of water. The fishing vessel, despite being well-built and properly equipped for rough weather, was quickly overwhelmed by the extraordinary sea conditions. The combination of massive wave heights, unpredictable wave directions, and the steepness of individual waves created forces that exceeded the boat's design limitations. Within minutes of the onset of the extreme conditions, the vessel was taking on water and losing structural integrity under the pounding of waves that seemed to come from all directions at once. Emergency procedures were activated as the crew fought to maintain control of their vessel in conditions that challenged the very limits of seamanship and vessel design. Distress signals were transmitted to coastal authorities and other vessels in the region, though the extreme conditions made rescue operations extremely dangerous and potentially impossible in the short term. The screaming sounds that had preceded the dangerous wave conditions continued throughout the emergency, seeming to intensify as the vessel's situation became more desperate. Crew members later reported that the sounds appeared to be coming from the waves themselves, as if the chaotic water was giving voice to its own violent nature. The acoustic phenomena added a supernatural dimension to an already terrifying maritime emergency. Despite the crew's experience and training, the extreme wave conditions proved to be beyond their ability to manage safely. The fishing vessel was ultimately overwhelmed by the massive seas, capsizing in waves that witnesses described as mountains of water that moved with unprecedented violence and unpredictability. 2 crew members were lost in the disaster, while survivors were rescued by other vessels that had responded to the distress call despite the dangerous conditions. The loss of the fishing vessel and its crew members marked another tragedy in the long history of the Agulhas Current's maritime casualties. However, the acoustic phenomena that had preceded the disaster raised questions about whether the screaming sounds might have served as some form of early warning system for the dangerous oceanographic conditions that were developing. Investigation of the incident revealed that the extreme wave conditions had been generated by a particularly violent interaction between the Agulhas Current and a Southern Ocean storm system. This type of interaction is known to create some of the most dangerous sea conditions found anywhere in the world's oceans, with waves that can reach heights exceeding 60 feet and possess characteristics that make them capable of overwhelming even large commercial vessels. The screaming sounds reported by the crew appeared to be related to acoustic phenomena generated by the turbulent interaction between opposing water masses and wind systems. When powerful currents encounter opposing weather conditions, the resulting turbulence can create acoustic effects as water is forced through pressure gradients and around underwater obstacles. These acoustic signatures might serve as early indicators of developing dangerous conditions. The specific characteristics that made the sounds resemble human screaming likely resulted from the frequency ranges and pressure dynamics involved in the turbulent water movement. As opposing water masses collided and created complex flow patterns, the acoustic signatures generated by these interactions coincidentally matched frequency patterns associated with human vocalizations under stress. However, the timing and intensity of the acoustic phenomena in relation to the development of dangerous wave conditions suggested that such sounds might indeed serve as natural warning systems for maritime hazards. The screaming sounds had provided nearly an hour of advance warning before the sea conditions became life-threatening, potentially offering enough time for vessel evacuation or emergency preparation if the acoustic signals were properly understood and interpreted. Modern oceanographic research has documented various acoustic signatures associated with dangerous current interactions and wave formation in regions like the Agulhas Current. Advanced monitoring systems now use acoustic sensors to detect and analyze these sound patterns as part of weather and sea condition forecasting efforts, though the specific acoustic phenomena reported during the 1995 incident remain difficult to replicate or predict. The tragedy has influenced safety protocols for fishing operations in the Agulhas Current region, emphasizing the importance of monitoring subtle environmental changes that might indicate developing dangerous conditions. The potential for acoustic phenomena to serve as early warning signs has led to increased interest in training mariners to recognize and respond to unusual sound patterns that might indicate maritime hazards. For the surviving crew members of the 1995 incident, the screaming sounds that preceded their vessel's loss remain a haunting memory that fundamentally changed their understanding of the relationship between the ocean and human perception. They describe feeling as though the sea itself was trying to warn them of impending danger through vocalizations that transcended the normal acoustic environment of maritime operations. The Agulhas Current continues to challenge mariners with its combination of extraordinary power and unpredictable behavior, where conditions can shift from navigable to survival mode within minutes. The screaming sounds that echo from its turbulent waters serve as reminders that the ocean possesses forms of communication that we are only beginning to understand, acoustic languages that might hold keys to predicting and surviving the sea's most violent moods. Outro, the ocean's eternal song. As our journey through the screaming ocean draws to its close, we find ourselves standing at the edge of a vast mystery that spans the entire planet. From the ghostly echoes of century-old disasters to the warning voices that rise from active volcanic formations, From phantom radio transmissions to the acoustic heralds of geological violence, we have explored 18 tales that reveal the ocean's capacity to speak in languages we have yet to fully comprehend. These stories, drawn from every corner of the world's waters, share a common thread that challenges our understanding of the marine environment and our place within it. They suggest that the ocean is far more than a passive body of water, but rather an active, responsive system that communicates through acoustic means that touch something primal in the human psyche. Whether these screaming voices result from complex geological processes, unknown biological phenomena, atmospheric effects, electromagnetic anomalies, or something that exists beyond our current scientific paradigms, they serve as powerful reminders that the sea retains its capacity to surprise, mystify, and humble those who venture across its surface or into its depths. The acoustic mysteries we have explored span the full spectrum of marine environments, from the crushing depths of oceanic trenches to the sun-drenched surfaces of tropical reefs, from the ice-bound waters of Antarctica to the volcanic cauldrons of mid-ocean ridges. In each case, the ocean has found its voice, speaking in tones that range from whispered warnings to thunderous proclamations of its power. Perhaps what makes these stories so compelling is not just their mystery, but their humanity. In every case, the screaming ocean seems to be attempting some form of communication with the humans who encounter it. Whether offering warnings of impending danger, seeking rescue for souls long lost, or simply bearing witness to the dramas that unfold upon its surface, the ocean's voices carry emotional content that resonates with our deepest fears and hopes. These tales also remind us that for all our technological advancement and scientific understanding, we remain newcomers to the marine environment. The ocean has been speaking its acoustic languages for millions of years before humans evolved the capacity to hear and interpret its messages. We are still learning to listen, still struggling to understand the significance of the sounds that rise from the depths. In our modern age of satellite navigation and instant global communication, it might be tempting to dismiss these acoustic mysteries as relics of a more superstitious past. Yet the stories we have explored are remarkably contemporary, featuring modern vessels equipped with sophisticated technology and crewed by experienced professionals. The screaming ocean appears to be a phenomenon that transcends technological progress, manifesting equally to ancient mariners and modern researchers. The common thread that runs through all these tales is the ocean's apparent awareness of human presence and its seeming desire to communicate with us through the universal language of sound. Whether these communications represent warnings, pleas for help, expressions of distress, or something entirely beyond our comprehension, they suggest a relationship between humans and the marine environment that is far more complex and intimate than we typically acknowledge. As we face an uncertain future, where climate change and human activity continue to alter the ocean's fundamental characteristics, these acoustic mysteries take on new significance. They remind us that the sea is not a silent, passive resource to be exploited, but a dynamic, responsive system that may be trying to tell us something important about its changing condition and our role in that transformation. The screaming ocean also serves as a bridge between the scientific and spiritual dimensions of human experience. While we strive to understand these phenomena through rigorous scientific investigation, we cannot ignore their profound emotional and psychological impact on those who encounter them. In the end, perhaps both approaches are necessary to fully comprehend what the ocean is trying to tell us. As you return to your daily life on dry land, remember that beneath the waves lies a world of voices that continue to call out across the darkness, reaching through time and space to touch the consciousness of those brave enough to listen. The next time you stand at the ocean's edge, pause for a moment and listen carefully to the sounds carried on the salt breeze. What you hear might be nothing more than the natural voice of wind and wave. Or it might be something far more profound, the ocean itself, speaking in tongues we have yet to master, singing songs we have yet to learn, screaming truths we have yet to acknowledge. The screaming ocean remains what it has always been, a reminder that our world still holds mysteries that challenge our understanding, voices that call to us from the unknown, and secrets that may never be fully revealed. In its cries and whispers, its warnings and lamentations, we hear not just the voice of the sea, but the sound of mystery itself, eternal and inexhaustible. calling us to venture beyond the boundaries of the known and listen for the voices that echo from the deepest places of our blue planet. The ocean's song continues, as it has for millions of years, waiting for those with the courage to hear its message and the wisdom to understand that in the screaming depths, the sea may be telling us the most important stories of all.